How come you're here?
Oh, sorry. Yes, I'm a PhD student at the University of Leicester, and I'm in third year and the final year of my PhD, and that's why today I'm here.
What is your PhD on?
So it's basically mostly on genomic interactions like mitochondrial and nuclear interactions and their influence on telomere length.
What?
Telomere length.
Nice.
Okay.
And aging.
Okay. And
All right. Anybody here aging? So that's relevant to you. So let me just get. Sorry, I didn't get you. What's your name?
Farnoosh.
Farnoosh and
Lucy.
I'm Mikey. And who have we got over here doing the pottery?
Oh.
That's you.
Hi, I'm Margot.
Margot. Okay, so we're talking about aging. We're talking about telomere length. You're doing a PhD. Any questions about this?
What is the thing that you think is most misunderstood about your area of your PhD? Have you done much talking to the public about it?
Actually, not that much yet. But the most hidden part is data on mitochondrial transcriptomics and genomics. So I'm just looking for some hidden parts that I couldn't find it during my PhD. Just
Okay,
trying
so
to
you're looking for. I guess that's what scientists do. They look for hidden things, don't they? And where are you looking for the hidden parts? Can you say?
Mostly through some.
Yeah.
Finding some connections that are giving some related talks today and tomorrow. So I'm just trying to find more connections and talk to them about that.
All right. So, mitochondria. Anyone got any mitochondria? Yes, you got some. Yeah.
I'm not a scientist, which we'll show very shortly, but I remember when I was a teenager, I was reading books about kind of paranormal activities and conspiracy theories. That's before I knew the conspiracy theories. So I didn't realize. I was like, oh shit, that must be real. And there was a theory that the reason why people combust, spontaneously combust, which apparently is a thing, is because the energy in mitochondria, how do you say it? Mitochondria, somehow there's some kind of a gap and the energy just kind of adds up from one mitochondria to the next, and then somehow that creates enough energy for somebody to just burst into flames. So, is this true?
Okay. Can the energy from mitochondria be so powerful it leads to a person spontaneously combusting? That's what we're talking about here. Any views on that, Farnoosh, Lucy? Maybe, have you ever spontaneously combusted? That's what we're talking about here. Come and join us. Any views on this?
I personally haven't spontaneously combusted.
Yeah. What's the closest you've got to spontaneously combusting?
Working with certain colleagues.
Yeah. Yeah.
Good to say that's where I'm at. I'm interested to know about what we can learn specifically from mitochondria over just our normal DNA. Do you have any thoughts? Anyone know?
Is it all the same DNA in mitochondria? Is it pretty much the same as?
No, actually, no. It's completely different in terms of size and the structure and everything. So it's basically very different from the nuclear genome.
Yeah. When they did this whole human genome project, did they include the mitochondrial?
No, they basically mostly focus on. I mean, the mitochondrial genome is also fully decoded and everything is known about it, but not at the same time as the human genome. Yeah.
So it's a bit of a sideline. Okay, come and join us. We're talking about the mitochondrial genome at the moment. We're talking about spontaneous combustion. We're talking about, yes, what is there to know about the mitochondrial genome? Yeah. Is it the same in humans as it is? Is it roughly the same?
Yeah, it's basically the same, yeah.
Okay. Go on, Lucy, say something.
Is it the same in animals as it is in... and it is identical?
Basically not identical, but yeah, there are in human cells and even in plant cells.
So does that mean that the transferability of information that you find out from mitochondrial DNA is better than normal DNA?
I can't can say that like maybe no, but you know the mitochondria is like less. I mean, it encodes less protein, less genes, so basically you get a lot more information from nuclear genome, but you only inherit the mitochondrial genome from your mother, so basically a lot of like disease and anything you get from mitochondrial genome, it's basically coming from the mother.
Is there anything in that in the mitochondria itself that comes out of the main nucleic genome? Is there any effect? Because obviously the mitochondria is sitting there in the cell. Is it affected by the big one?
Yeah, definitely.
Yeah.
A lot of like proteins that are like functioning in mitochondria, they are encoded in nuclear genome.
Okay. All right.
So that's what.
Okay.
All right, so as always, we find in the Festival of Genomics actually more complicated than you ever thought. So, I mean, how do you deal with this complexity? Is it just something that you're used to?
So I haven't had the chance to attend like lots of different festivals or conferences, but it's gonna be like the second or third conferences I'm attending.
Yeah.
But my first time in Festival of Genomics, and it sounds pretty like crowded, busy, noisy compared to other places.
Yes, it's
but
a crazy maelstrom of stuff going on. Yeah, I mean, what kind of things are you hoping to find out?
yeah, so basically I'm just hoping to find like more connections and more like expert opinion about what I'm doing in my PhD.
Okay, so maybe we can find some connections. Maybe these people come and join us. 2 seconds, yes. We can find a connection here. We're doing it for you. So we've got Lucy, we've got Farnoosh, I'm Mikey. What's your name?
Mimi.
Mimi and
Radia.
Radia.
Yeah.
And I'm Mikey. At the moment we're talking about Farnoosh is doing, I don't know, I mean I'm not a scientist, it's something about mitochondria, it's something about interactions, something about aging, something about telomere length or something like that. Anyway, so that's what Farnoosh is doing, something like that. Lucy, what brings you here?
I'm just like really interested to hear more about how the public interact with co-creation, public involvement.
Yeah.
That's what I really like to try and understand. And
Okay,
know about.
can the public get their head around things that you're researching? What about you on this side?
Well, I'm a student. I'm doing my master's in genomic medicine,
Yeah.
and I'm here to kind of like find out about the like frontiers of genomics right now and get an idea of like future career prospects, hopefully.
Okay, what kind of career are you potentially looking for?
Yeah, so I used to work with like biomarker discovery in like a pregnancy cohort, so I'm pretty interested in working around that, going back to that. So I'm trying to see and find institutions that probably do like integrative multi-omics.
Right, okay, I've seen a lot of those. Come and join us, yes! Yeah, you can come over here, it makes us look more busy, it's better. Come to our carpet shop. What about you?
I'm also doing the same program in genomics medicine, but I come from a more wet lab background, but there is a lot of like sequencing and target discovery things that happen, so I'm just scouring and browsing
Just got your
around.
eyes peeled to see what is new, what's happening.
Yeah,
Okay.
it's quite exciting, yeah.
Okay, so you're talking about multi-omics. Where do we want this conversation to go? Yes.
What are the type of biomarkers that you were looking for in pregnancy, and what did they lead to?
So we were doing some scanning with, we were doing sampling at like 2 stages of gestation, and we were mainly, I was mainly working with metabolomic markers. They're mostly lipids, spoiler alert. But no, it's some really like surprising fatty acids came up, which were like elevated in late stages of pregnancy when you were looking at like patients that had preterm birth. Some others came up when you were looking at small for gestational age. Mostly we were working on this because like back home where I come from, they have like a really high rate of maternal and like fetal mortality based on like, that's Bangladesh.
Right.
And so so the research was mainly focused on like how we could discover biomarkers, potentially turn them into like like sampling, testing that could predict outcomes and prevent them in the future. But that being said, that's probably like a really long way to go.
Right, so we've got Lucy, we've got Farnoosh, Mimi, Radia, tell us your name.
Maria.
Maria.
Yeah.
And I'm Mikey. At the moment we're just kind of finding out what people are doing. Farnoosh is here to make connections. Radia's here to find out stuff, to find out what's new, maybe in the world of multiomics. But it seems to be you also got some interesting facts about fatty acids in pregnancy. Do fatty acids come under some kind of, is there a fatty acids omics? That's a question. Because, you know, it's all proteomics, but where's the fatty-omics?
Lipidomics.
Lipidomics.
It's lipidomics.
Yeah, I think fatty-omics sounds better. But anyway, Maria, what brings you here?
I want to talk about something interesting.
Yeah, okay. Could it be anything? Have you got particular sort of...
About applying math in life science.
Okay, maths.
Yeah.
Okay. Do you find sometimes when people say maths, people kind of like, when you say maths, people kind of glaze over a little bit?
I don't understand.
Do people kind of like get, kind of just sort of stop concentrating when you say maths and just kind of...
I hope that's not, because most part of research is statistics.
Yeah, there's okay, statistics, more statistics, and more statistics.
That's what it's all about in research.
What's your maths game like? Are you...
Not great.
I enjoyed math until high school, but after that, it's been a plateau.
Yeah, okay, so maths maybe...
You're saying it's all statistics. Go on.
What do you think the use, like the computing power of like a supercomputer would be able to unlock if they were more widely used statistically?
Okay. What are the statistics that we're missing, maybe?
What statistic we missing?
Yeah, that if a supercomputer... I mean, we have...
If we have more widespread use of supercomputers and higher processing power, what do you think the biggest challenges would be that we could unlock?
Okay, what would...
I think the first problem is to have data, because to work on genomes we need to not thousands of people but millions of people, and now we don't have it.
Yeah. So you're hungry for data?
Yeah, I am very hungry for data, and then I am hungry for computational power.
I'm hungry for snacks. Okay. But data as well. Everyone, yeah, I mean, yes.
And so then that involves working with people, right? People are data. So what is the way to improve working with people to get more data? What's the best way, do we think?
How do we get more data? Do people agree with Maria that we need more data? Isn't there quite enough data? I mean, come and join us. Yes. Yes, come on. I'll explain what this is in a second. So this is Talkaoke Pop-Up Talk Show. We can talk about anything. Maria's looking for an interesting conversation. Farnoosh, you're looking for connections. You're maybe looking for a new job. So that's what's going on. We have got Lucy, we have got Farnoosh, we have got Mimi, we've got Radia, we've got...
Deirdre.
Deirdre. Deirdre.
Yes.
And we have got...
Jun. My name is Jun.
Jin.
Yeah.
And I'm Mikey. At the moment, we're just kind of like chewing the fat here, really. There's a few subjects on the table. There is the multiomics. There's lipidomics, which I just discussed. You learn so much here at Festival of Genomics. I've never heard of. Have you heard of lipidomics? Lipidomics.
No idea.
Yeah. Well, apparently there's lipidomics. Yeah. Just when you thought there were a lot of omics. Is there like a mathsomics? Like a numberomics or something like that, dataomics?
Yeah. All omics goes back to math, because it's like large data, and that needs math. Yeah.
So the maths is the omics side, not the thing you put on the front of it. Okay, anyway, so we have got Jin, we've got Maria, we have got Radia, we've got Mimi, we have got Deirdre, we've got Farnoosh,
Emilia.
and Lucy and Mikey. I'm not wearing my badge, it's over there. But yeah, I mean, where do we want to take this? Is it all about the maths in the end? Is it all, whether we like it or not? Is it all about the statistics, whatever omics or multiomics we go for? Is it really just about the maths and the data at the end of the day? Everyone's nodding, which kind of...
What do you think, Amelia?
I think, yeah, it's about the data. And for me, the most exciting part about the omics is now the possibility of using AI, because that's the most multimodal
Yeah.
data. This is like, for me, why AI was created for this kind of applications. I think it's huge potential there.
Okay. So, is the potential so huge that AI is going to be doing my job, your job, everybody's job, and all we're going to be doing is just, like, I don't know, I mean, what do people think about, do we agree with Amelia that it's, AI is going to be able to crunch all these numbers and just come up with the knowledge that we're all looking for? What do you think? Any thoughts? Do you have any thoughts on this?
Yeah, I think, of course, they'll be able to process data, but to create knowledge for people is not an easy job.
Yeah.
They need to be able to know how we understand things, which is the forefront of neurobiology.
Right.
It's cognitive science to understand how we think, and after that we can be able to communicate better with AI.
Okay, I mean, so AI needs to understand how humans think, how we conceive of things. That's quite, do we feel that AI does that already? Is it able to translate this world of huge data sets into something that's humanly understandable?
I think going back to what you said about math and like about math being really important and AI, but I think at the end of the day, the beauty of biology is that nothing is constant and everything is different. Like nothing is, you can't say this always happens, because there can always be an exception with biology, right? And so every person is going to be different. Every system is going to be different. So even though AI is probably going to take all my jobs, but at the end of the day, we kind of need to take into account that, you know, we need that kind of conception that things can be different, which usually prediction models don't really handle really well, at least now. I hope it stays that way.
Okay. So the question is, can AI deal with the this kind of incredible diversity of biological phenomena that it is all different. We're all different. Are we? I mean, do we agree with that? Are we for an AI? Are all the different people around the table that different, or are we just the same nodes in the?
I have a question: if humans can do it, can we do it?
Can we do what?
To combine all the data, to look at it, to make something out of it.
I mean, can the humans? I mean, this is a very interesting question. Can humans actually do better at networking with each other, and can we? Never mind artificial intelligence, can we actually grow our own intelligence?
Well, I think ultimately we can do it, just much slower.
Yeah.
Like we can all, right?
Yeah.
We're just slower.
We're just a little
It just makes everything quicker?
A lot slower, not a little bit slower. Yeah.
A lot slower.
Okay. Is there a big rush doing it? Can we slow down and go on a human scale, or should we just speed things up and go on an artificial intelligence scale? Is Lucy right about this? Can humans speed up? Do we want to speed up?
I think I'll have my last comment and then go to the next one, but I feel like it's quite ironic, but I'm a bit of a tech pessimist. I see a lot of potential in AI and being able to use genomic information to like guide treatment, but also there's this big question of like abusing data in general to target people, and I think I still am in that spectrum where I'm not completely confident about, you know, data generation, but also like in terms of fidelity, how accurately are we collecting data? So I'm still on the pessimistic spectrum.
Using data.
Like using data to like generate, because there are a lot of things that happens on our AI, right? We have hallucinations, we have like false data being reported. So I think taking that into consideration, like I'm still like, yeah, there's a lot of questions I have.
Okay, a lot of questions. Data abuse. I think it's an interesting line of conversation. Thank you for that, Mimi. And we're here all day. Are you going to go as well?
Yes.
If you do leave, give us a final thought.
I think there's a lot of potential in all of these applications and a lot that we still have to learn.
What sort of things do we need to learn? Is it about learning how to work with AI, or is it just learning in general, the general research we've always been doing?
I think there's a lot more that we need to learn to make AI work for us. And I think there will always be, like everyone has said, a human element that is necessary to make sure that the AI is working properly for us and not just regurgitating what we feed it. But yeah, I think this is a very exciting time to be in genomics.
Thank you for that. That's a very good final thought. Okay. Fanush, if you're going as well, give us the final, and you, Radia, give us a final thought. Final thought from everyone.
Yes, I basically believe like the same as Maria said. So it's just we need AI for the speed and like precision and everything, but at the same time, like there has to be like strict governance and rules to be like protecting the data and things like that.
Can you govern something that you don't properly understand?
I mean, we can at least like start by doing some governance and rules, just setting out some rules there. So basically, yeah, that's what I think.
Give it a go anyway.
Okay, come and join us. Thank you, Fanush. At the moment we're talking about AI. Yes, I mean, we come here every year at Festival of Genomics. People are very excited about AI. There's not much skepticism. We've heard a little bit about it today, a little bit about data abuse, which is a new one. Yeah, so what do people think? Where do you want to take this conversation? Yes?
About AI, I'm very waiting for applying LLMs to the genome, because now we do genomes just by linear regression, but genome is language. So with context and with the spatial structure, so it's ideal for LLMs, but the problem is we need explainable AI. So I'm very looking for methods to explain how a large language model works, from which part of genome they learn or something.
So what you're saying, Maria, is that the genome is a language, so it's suited to a large language model. We just need an AI that will be able to explain this language to us. Do other people agree with that statement, Jim?
There exists. Novogene has already launched a LLM that applied to genomics that tell all of the expression is a language model. I haven't used it, but
what do you think about the concept of the genome as a language?
I'm saying it's true, because this is how the life talks.
Yeah.
They build up all those molecules and use them to produce the product that they use.
Yeah.
So I agree with it, and I'm also looking forward to this.
Okay, so, all right, so genome is a language, that's what people are saying. What's that?
I wanted to, I don't know how this works, sorry.
Well, I mean, it's basically talking into the microphone, but what was the question?
So, did you say Novogene?
Any direction.
Ah, amazing. You don't have like a topic. That's so cool. I thought you work at Novogene. You said Novogene?
Yeah.
Okay.
There's collaboration of Novogene with Oxford in developing new AI techniques for genomics. And I know one of my friends is working for Novogene. Yeah.
But Novogene is a sequencing company, right? They are more providing the service to the labs. So you say they are also doing some R&D and like design, like more different services as well. They're going into research.
That's a good question, because I didn't work for them. I cannot give an official statement of that. But as far as I know, now these companies are all developing handy tools for the researchers to understand the data that they generated. They do the sequencing, they generate the data, but they also provide visualization of what the data tells us. And this is a good way to do it.
The next step is to create an LLM for this visualization.
That's like, this is very obvious natural direction. I think this is what's happening and what has to happen. That's like the next, we are entering now a new era of genomics, and without AI, we are not using our full potential. This is like very natural next step. We did all the work, all the human work, all the basic fundamental traditional research, and now is the time for the AI era. That's what I feel.
Okay, so we've done the work. We we really meaning not me or you, Lucy, or you, but we in general have done the work, and now it's party time. We get AI onto it, and we can just expand this. Yes.
Yeah, we've done the work, and then AI takes our work and doesn't credit us.
We just doing more efficient work. We are working the same hours, but the impact we have, it's gonna be logarithmic expansion.
But is it because it's taking information that's been trained without the people's consent? So it's like learned loads of information about how to...
Okay, I'm just going to hold that because we've got a new face to the table.
We have got Margot, we've got Lucy, we've got Amelia, we've got Jin, we've got Maria, we've got...
My name's Christian.
Christian, welcome. I'm going to hit you with a round of applause. And my name is Mikey. We're talking, I'll just sort of fill you in on where we are. We're talking about the possibilities of AI. We've got Maria here who said, in the end, all these omics, it's all about the maths. You're a mathematician, is that right? Yeah, so then we started talking, you mentioned AI can sort of deal with this, and then we started talking about large language models. Is the genome a language? And if so, can we understand it through AI? What are the possibilities of AI? But then now Lucy's kind of saying, is AI just hoovering up all this data and kind of taking the credit for it, for some of the research that humans have done? Does it matter? These are some of the questions. Where we are right now. Have you got anything to add at this point?
I do indeed. So I'm a first-year PhD student, and I'm heavily involved with AI. That's actually what I'm doing my PhD in, is building new deep learning models for integration of multi-omics data. And I've got opinions, and I think both of you guys are probably like I think you're both in the right here. I think there is certainly a data safety concern. So I think, getting access to people's health records is not something that needs to be taken lightly. But we've done it before, and people have been using health records for research all the time. I think it's just a matter of scale, and as we step into an age of hyper fast processing and getting models that really are there for investigation. We're not using it to solve problems, we're using it to help curate our decisions and spend our resources better. I think knowing where that data is being used is of utmost concern. I think at the same time, we need to know that AI is still a tool, and it's not going to solve all the problems that we're dealing with. So being able to curate and set boundaries and architect smartly is also another thing. So it's not like a savior tool that's going to go through and kind of, in my opinion, take all of our hard-earned work away. I think it becomes an assistant, and it becomes a tool that we can leverage a little bit more actively. So that's my opinion. You let me know.
Okay, what do other people think about that?
I think that artificial AI is making a lot of work for mathematicians, so it's the reason that I have a job.
Okay, so you're not losing a job from AI. You're actually got more busy.
Math is going so much interesting when we are in era of data and AI, because statistics is very hard for people that are not mathematicians.
Okay, yeah. Statistics, all about statistics, but it's hard for most people, but not for you. That just doesn't seem fair. It's hard for you as well. Okay.
Yeah.
Okay, that sounds better. Okay, so we've got Amelia, we've got Jin, we've got Maria, we've got Christian. What's your name?
Carlo.
Carlo, welcome. And we've got Lucy over here and Mikey. At the moment we're talking about AI. You mentioned Christian as well. Yes, it has to be regulated. Can we regulate something we don't really understand? There's a question there. Maria, you've got something?
In a question about statistics and maybe not about deep learning, but big data. What do you think about the problem of multiple testing?
Go and say it.
Because when we test, it's very visible in genome-wide association study. Because when we have genome, we have 1.5 million of variants. So the chance that we have some results just by random, it's very, very large chance. So we need to consider very low p-values to obtain anything. and this is about all work which tests hypotheses. Much of results are obtained just by random, and it's math.
Okay.
And what do you think about it?
Okay. Does everyone get the question? When you've got such huge data sets, you're gonna get some sort of random connections. So your p-value has to be quite low. What do people think about that?
So I'll just pass it to you. But I think it raises a really important question, which is, we're at the forefront of both statistics and biology. And so when we design these models, which are inherently statistical, they need to make biological sense, and they need to be working on questions and working with architectures that, one, work well with the statistics and the data that we're working with, but two, answer actual biological questions. So picking the right metrics, deciding how we curate the data, deciding how we format that data, it all needs to make sense on both those planes simultaneously to really get systematic insights. So I think our job now is, we've done a lot of work in the statistics, and it's only going to keep growing. How do we then use biology as almost like the applied medium for the statistics? How does it then become the actionable, format of how does biology become the example and the actionable, tangible kind of result of the statistics? So again, these AI models can't work in isolation. They can't work in a vacuum, and they need to be asking questions that make sense for both.
Okay. It's all about asking the right questions, no matter what the statistics are. Carlo, have you got any views on this? Amelia, I feel like I've been ignoring you there. Carlo, have you got any views on this? What brings you to? Are you a data person?
No, I'm a business person.
Okay.
So.
Surely there's some data in business as well.
Yeah, of course. Yeah.
What kind of business are you?
So I'm working for a bioinformatics company that provides services in different bioinformatic needs of companies, pharmaceutical companies, biotech companies, academia, science groups, and we help them make sense of their data.
Yeah, okay, well, you might be quite useful here to help us make sense of these questions. So, what do people think? Amelia, can you say something?
Yeah, I think there is huge limitation, like you said, but as the same in traditional research as well. I still think it's the way to go.
Okay, so it's the same story. I remember when I did biology back in the Stone Age, we still had statistics, but it was all tables and calculates. Come and join us. Yes, we're talking about lies, damn lies, and statistics, as Benjamin Disraeli said in the 19th century. Is it all about the statistics? I mean, have we got that interface right between the biology and the statistics? Is biology in the end just a kind of statistical discipline? Is there more to it than that? And why do we all find statistics so hard, even the mathematician?
Because statistics relied on the probability theorem, so there's a lot of underground to understand it.
Yeah. Okay, so it's not. I mean, it's kind of interesting that we are biological beings, and that we've kind of established that biology is mostly about statistics. And why do we find it so hard?
Maybe it's an issue of dimensionality. So we're looking at different scales simultaneously, and those, scales work together to produce really, really complex patterns of expression. And when you look at them from almost like, they have a field systems biology that does this all the time. It's breaking down biology as an engineered system, and how does that work? When you look at scale, right, statistics works really well at reducing scale. But here we're talking about so much information, so many ways to regulate it, so many conditions, and that system all needs to be adaptable. So
Give us a final thought, Carlo, before you go.
would.
Good luck. Okay, thank you. Well, good luck to you, and hopefully you can sell your bioinformatics services across. I don't know if we've got any buyers here.
Hi, I'm just curious, Christian, about your topic, your PhD topic, if you want to say, if it's okay.
So I really like multimodality. Multimodality is one of the really interesting, new frontiers for AI integration. So everyone knows RNA-seq data. That was a huge deal for people. But RNA-seq is just one piece of the puzzle, and when you look at a living system, it's more than just RNA-seq. You've got, your proteomics, you've got, your metabolomics, your metallomics as well with the different ions. So being able to collate those different data sets into a meaningful image, right? That's really the next big challenge.
I mean, you say RNA-seq is just one piece of the puzzle, but when you've got a puzzle, you know how many pieces there are, it says on the box. But do we really know how many pieces to the puzzle there are?
Not yet. I think that's the fun bit. It's kind of all picking and choosing what makes sense for the question that you're trying to ask. So I ask you guys, what do you think then? What is the essential data? What can we afford to leave out? Can we afford to leave anything out? And what do you think that means for, how fast we're able to solve these problems? Because more data means more time. So
I have a final thought. I'm also leaving. About this question, I would say, yes, we are biological being. But to me, biology is kind of statistical thing. The contact of molecules are quantumized, and every status, every decision we made is possibly randomized. So statistics is the very key things to understand biology. But the reason why we are so bad at it, possibly because we don't have the enough energy and the time that is required to understand. So we are created by someone that is better than us for some reasons. And in the future, that's why we are good to use AI. We designed AI to let it do something we are very bad at, because it's highly specialized and it used the minimum energy to deal with the problems that are most complex to us. That's my hope to the future, and I wish everyone has done a good job with AI.
That's an excellent final thought. Thank you, Jin. Okay, so this is Talkaoke. It's just a random pop-up talk show. We have got Amelia, we've got Maria, we've got Christian, what's the name?
Peyton.
What's it?
Peyton. My name is Peyton.
Peyton.
Yeah.
I'm Mikey. We've got Margot over here at the moment. I mean, it's kind of the whole point. It's kind of up to you where you want to take this conversation. There was a big kind of mic drop from Jin. Are we kind of statistical machines? Are we statistical entities as biological beings, or are we just something different? And if we are, why don't we understand it? So there's that question, but there's also your question, Christian, which is like, essentially, where do we stop? As we're trying to understand these complex interactions, do we just bring in all these different omics, some of which I've never heard of before? So there's that question. Where do you want to take this conversation, or do you want to go in a different direction? Amelia?
Yeah, I want to follow up on Christopher, because it seems like it's a perfect PhD topic to join this table. It's amazing, because I think that's exactly the point here. That's exactly where we can leverage AI, where humans cannot find all these small correlations between completely unrelated data sets. And I am doing very similar thing, but generating this data, and I am like the end user of your models that you will come up with to integrate very different omics in my case. And yeah, I'm very excited to hear about your stuff, and we should talk as well.
We're doing the talking now, and everyone else is hearing as well, so that's good. But maybe we can keep that going. Come and join us. We're having a multi-omics discussion here. Peyton, have you got any views on this? Are you picking up what we're putting down?
I'm just in here, so I want to do a bit of pick up what you're talking about, right?
Multi-omics. We're talking about lots of multi-omics integration, what that means for the future, and how we think we're going to do it.
In DNA, RNA, protein level, multi-omics.
Even more than that, we can talk about how metabolites move around. We can talk about, how organelles, are signaling to one another. So there's lots of different ways you could cut this cake, in deciding what tiers what slices of the cake you want to include in your analysis is all pretty defining. So how do you do it? What do you include? What do you leave out? These are all the questions that we have to ask ourselves and that we don't really have answers for right now.
I mean, I get the feeling. Come and join us. We're talking about multi-omics. Christian's asking, how do we cut this cake? And it seems like the cake is getting bigger and bigger all the time with all these different omics that I've never heard of, like not just this, every time we come to the to Festival of Genomics, which is once a year, there's more omics. We heard earlier on we had lipidomics, but you were talking about
metalomics. It's like ions that move around and have physical interactions with different molecules, so altering their properties and functions, and it's all very new. And it's where do we draw the line? What do we include and what do we leave out?
It seems like there's just this, there's this kind of like, especially with AI, there's this kind of drive to include everything, include all data, all interactions, but then that just kind of blows your mind, and how do you actually draw conclusions? I think that's the question. So we've got Amelia, we've got Maria, we've got Christian, we've got Peyton, what's her name?
I'm Sarah. Sarah.
And Mikey. Yes, that's what we're talking about, the multi-omics. Do we just go with it? Do we invent some new omics? What are the omics of the future that we're going to hear about?
That would be instrumental issues, let's say protein level. That was we don't have a standard for detect proteins, and then let's say proteomics itself, it always has variations. They need to match with a library to see the specific product, for example. So the uncertainty on the reliability for proteomics level, I feel is a bit over-optimistic, statical at the moment. This is my opinion. And I think DNA, RNA level right now is well developed and quite reliable, but we need to more focus on the unreliable things, for example, proteomics, and then maybe metabolites at the same time as well.
I mean, how would we do that? Do people agree with that? Do we need to get a bit more reliability with the proteomics? What does that look like?
I think one of the most important questions is what you're going to do with it. So what can we do? Fine, but what are we going to do? Why are we going to do it? And therefore, how do you make the choices about which direction you go? Because it seems to be like there's an expansion of what you can do, but actually, how you use it and how you apply that is still, I think, quite a way behind from what I see.
Okay, so what do we do with all this knowledge? I think the answer that we've come up with so far today, before you arrived, is we feed it to the AI and let it draw some conclusions. But is that good enough? Come and join us. What are you going to feed to the AI? What do we think? I mean, there's sort of two directions with this conversation. Do you want to talk about making proteomics more reliable? Do you want to talk about what do we do with this knowledge? Where do you want to take this conversation? Any thoughts?
So I like the point that you make, which is we've kind of sat in the middle of two different battles. One for higher quality data. Proteomics still isn't reliable yet. You're right, but we do have access to a lot of high quality data as is. So I think using that existing data is going to be really important. And you do bring up a really good point, which is how do we best represent and use that data. So I think having tools that are able to navigate tabular data right now, which is really, that's the RNA, that's the genomics, that's all that kind of the data. We need to be able to look across that in an efficient way, which is actually, that's like a task that's been kind of thought about for a really long time for natural language processing, and how people understand text translation and generating new text, generating new paragraphs of information. And so then we ask ourselves, okay, well, where does it fit within this ecosystem of research? What do we really get out of it? We're putting in all this work. What is it all for? We've had this, kind of pipeline of science that's stayed pretty robust for the thousands of years that we've done science. So where does it fit? That's kind of also an ongoing question. So really and truly, it's still a frontier, and I don't think anyone's got a real answer for it yet. But I do think we've got a great starting point. So lots of RNA-seq data sets have been coming out, lots of different models are being tried, different architectures. People are including models that were once used for a completely different application, and now bringing them into biology, and they're having some promising initial results. So there's a model that recently came out called SquidIF, and it's a diffusion model that was used a lot for image processing, and that was, people were like, okay, well, it's useful, and it was used mainly before we invented transformers, and used transformers a lot for image processing, and so it then kind of was put back up on the shelf at least for image processing and image generation. But now it's kind of found a new home in biology, and people are really trying to understand, at least with this particular system and this type of architecture, adding noise to data to then be able to take it off and that be part of the learning process. And right now it's looking kind of promising. So how do you take old tools and apply them to new problems and make that make sense?
All right. So we have got Amelia, we have got Maria, we have got Christian, we've got Sarah, we've got Peyton, we've got Margot, we've got
Brad. Nice to meet you.
Welcome. I hit you with a round of applause. And Lucy, we've got over here Mikey. So we're talking, where do we want to take this conversation? It's kind of up to you. I feel like your question maybe was slightly ignored. What do we do with all this knowledge, all these extra omics that, okay, we're going to make proteomics more reliable. What do we do with that knowledge? But then there's this very exciting idea about just even taking different kind of models and applying them to biology. Maybe that's just that's actually, I don't know, that's a more exciting question. Where do you want to take this conversation? It's kind of up to you. Maybe we can talk about the,
I'm very curious about what practical question can be answered by integrating this multi-omic data.
Okay.
Yeah, because for me it's terra incognita. I'm not a biological field, so.
It all seems to be a bit nebulous right now. Yeah. So I think pathogenicity is a really big one. So trying to understand where disease comes from. And the genetic basis behind disease. We find, evidence of that in the genome. We find evidence of that in gene expression profiles. But looking at those things individually, again, it only just gives you kind of one look at one perspective on this on one big problem. So I think being able to collate different types of data sets together in a way that makes biological sense is really interesting and not something that we're able to do very well right now. So I think that's where we're going.
Okay. So I have some answers to those questions because that's basically my job. And we can, for me, it's about understanding how life works and how genetics and gene regulation works. So you can find, by integrating all these different elements that seem unrelated, it's part of one big system in the cell. So I'm looking into chromatin, into epigenetics, into the nucleus, and you can find new gene networks, for example, from combining proteomics, RNA expression, all the different stuff. And the amount of questions seems to be infinite, to me at least, that we don't even know how much is still there, that we have the data, but we have the data, but we don't even know how much we can still get from this data. So it's very exciting. I gotta go now as well. Thank you very much for amazing format. Thank you. Thank you.
Okay. Well, it's good that everyone's very excited about it. And you're saying, Amelia, we've only just kind of started on the conclusions we can draw. Sarah, give us a final thought before you go.
So I think there's something about integration of the data, and I think there's when in terms of clinical outcomes, I think if you're talking about your big data, there's also, in reality, if you're thinking about the NHS, you're thinking about how that gets stuff. There is this kind of mismatch, to my mind, of not being able to access a computer while you're on a ward and trying to kind of, get somebody kind of through the hospital, and then actually all of this kind of really high science, and I think there is going to be contexts where you get those things right, and there's going to be stuff where you have huge amounts of missing data. So I think there's a kind of aspect of you need that clinical data as well parameters so you know what outcomes you're looking for and what's the relationship. So that's where a load of stuff needs to be done practically as well. I'm maybe a bit of a skeptic about that because I think it's kind of like we need those two things together in order for this to be informative. Yeah.
Okay, so there's a little bit of a missing link between all of this exciting research and the clinical application.
It's pragmatism as well, and I think it comes back to that question of okay, you figure this stuff out, and I think we're a bit for some areas. We will be in a position where it's like, okay, can directly feed into kind of clinical decisions. For some areas, we're miles away from that. And then other areas, we're kind of trying to figure out, okay, how do we use this data? How do we get into a cloud environment and things? So there's loads of practicalities that when you're looking at kind of cash-strapped health settings, we need to figure out where we can best focus as well. So where we're going to get most bang for our buck in terms of where you're going to get that kind of benefit. And I think often, in terms of like primary research, always, I think the links are always going to be, can always be improved between primary research and application in anything, but this is definitely one of them.
That's an excellent final thought, and it leaves us with a big question. How do we match this up? Is there any sort of clinical application at all, or is it just kind of fun science that you're talking about addressing disease? Thank you, Sarah. You can stay if you want to, though. You're talking about disease, but are you some kind of clinician there?
Okay, great.
Yeah, and maybe anyway, but it's the first time people have talked about, okay, what is the clinical application of this? Are we a million miles away, as Sarah said, for clinical applications, and actually some of this research being useful in some way to people that are not scientists?
Yeah, I just want to follow up something. When you collect clinical data that's from clinicians, and when you ask a patient, you may not ask every detail on it and a lot of missing information. So also when you do multi-omics data, you also maybe have a failed samples in maybe in one specific level, for example. So it's really difficult at some point. We got missing part in there, missing part and somewhere else, and in the end, because it's multi-omics data and the sample size also maybe not enough. This is quite challenging, to be honest. Yeah, thank you.
Okay, so it's a big one. That's a mic drop. Brad, I want to bring you in on this. Have you got any views on the conversation so far?
So I work in aging. We're trying to figure out what aging is, what it isn't, and we don't know. So a lot of what we're doing is taking as much data as possible from our data people, from our multi-omics people, because I'm not a data person. I'm a person who works with people in a lab or in a hospital. What's that?
Good luck.
Yeah. There's so many people in this building, I should be just sampling everyone. But we don't know what we're looking for. And so what we tend to do is gather as much data as possible. And then sometimes I think we're clouding the picture and overdoing it. And more data isn't always better for us. Yeah. Do you know what I mean? Or am I wrong? Like, I'm just learning this stuff as I go.
Okay. Go on.
Where does, I guess, GDPR come in when you're collecting data? And you should only collect data that you need to collect. And if you say you don't know what you should collect, how does that work?
Okay, so there's a little bit of a paradox there, because all of the people around the table, they're data hungry, aren't they? You're data hungry. But how does that work when you're only supposed to collect relevant data? How do you know what's relevant?
So I really like the point that you bring up, because it speaks to resolution, right? We're looking at a very specific problem in some cases. Aging is, you correct me if I'm wrong, it seems like that's a very broad, topic. You're talking about cell-senescence, you're talking about...
We don't know what it is.
Exactly, right? Yeah. And it feels as though that you really, sometimes you don't know where, maybe you could start from many different places. So I think you're right. Getting too much data clouds probably maybe where you started off, but I think that we don't know. Like you said, we don't know. So maybe we are erring on the side of caution in getting more data, and maybe that down the line proves useful. But I do like the point that you brought up a little bit as well, which is this idea of compliance, and what are we really allowed to get from people? I think it touches a little bit more upon the idea of clinic versus research.
I mean, do you think it's dangerous to gather extra data that maybe is relevant, maybe not relevant, to have this broad data?
From the clinic, maybe. From the clinic, maybe, we'll get to a stage where that becomes more important, but I think right now we're talking very much like this whole, the scope of AI inclusion into research is, in my opinion, should be kept to research right now. And I don't think that when we talk about, patient outcomes and talking about, the real world impact on people, I don't think we're there at all yet. I think the forefront maybe is drug discovery. People are looking at finding new drugs that can apply, and people, can then go ahead and run those through the more traditional clinical trial processes. But like you said, we're missing data. Those data sets need to be harmonious when we're managing multi-omics. It's a really hard thing, and I think people maybe and this is someone that works in the field, there is a lot of hype. So we'll have to see where we go. We'll have to see what kind of impact we can have in the clinic. But for now, I want it to stay in research.
Okay. I mean, there's so many different ways we can take this conversation. And I will say this again, it's kind of up to you. Do we want to go on to the sort of like more data, more problems kind of thing? Is data sometimes, are you off? We want final thoughts from people. If you leave, give us a final thought. So where would you like this conversation? I know you're leaving, but where would you like this conversation to go?
I don't know.
I mean, are you interested in the kind of clinical application? Because we had Sarah, she left almost immediately, but she's like, what about this, okay, all of this research is great. What about how does this work in the clinical setting? How do clinicians feed their data in? Is that something that's concerned you?
I think the very interesting topic is how the research is replicated in clinical, and this process is very I'm curious about.
Okay, so it's maybe a question. Okay, final question for you, Maria. Thank you. Hit with a round of applause.
I think to kind of address. Before I go, I think the idea of AI as a bit of an implementing model seems as though it's like one big thing, but I think it's more of a framework. Finding a solution that works best for your lab, the work that you find important is more important, right? There's a very well kind of used quote, which is all models are bad, but some of them are useful. So I think designing something that works well for you is more important than having something that works well for everyone and solves all the questions. It just has to be realistic, and it has to be personable and understandable.
Okay, that's an excellent final thought.
Final thought?
Yeah, go on then.
Okay. I feel maybe in the future we should use AI obviously, but AI model itself, is it reliable? Yeah. Because a lot of black box when you run the AI. How can we solve the black box issues in data to generate the outcomes, reliable outcomes, and we trust the outcomes at the same time? So a lot of regulations, I believe, and how maybe clinicians or even a patient itself believe the outcomes from AI solely.
Amazing. Welcome to the People's Talk Show here at the Festival of Genomics. This section we're entering into is about science communication and creativity. Has anyone talked to the public about their work? Would anyone like to join us? What do we want to talk about here? I'm a little bit smaller on this chair, I think, than B2B. Okay. So what do you think? What do you understand? Are you a member of the public? Are you an expert? What do you understand by genomics? What do you?
No, I think it's fine that you mentioned about the low chair, and I think the problem of kind of the ego in science communication could be something to talk about. If your chair is low, are you commanding us? I mean, not you, but I'm just riffing off the metaphor. But is there ego in science communication? Is that important? Does that get in the way? Does it help?
Yeah, well, why do we want to communicate with the public? Is it just for your public image, or is it necessary that the public needs to know about genomics? Do you think that it's necessary?
Way into that. So I'm 100% biased on this, and that I am a science communicator. It's literally part of my job description. And it's been really good for me personally. I love it. I get involved in science communication. I talk to strangers about my work. It's been helpful because when I was an early career scientist, I was rubbish at talking to people and I was rubbish at talking academically. But it's terrifying. Like, it genuinely is. Prepping for a talk with the general public is much more intense than prepping for a talk with peer scientists. because they ask some of the most interesting questions. Some out of the blue thing you never thought of. And it took me a long time to realize something like, it's okay to not know the answer to those questions. Because you're right, ego is a big thing. And you're supposed to be like that guy in the white lab coat who knows all the answers, which is the exact opposite of what science is supposed to be. So the biggest thing was realizing I didn't have to know and just being interested in the conversations we're having.
Amazing, thank you. So being able to talk to the public about your work is really helpful for you. It means that you can understand that you don't need to know everything. Is there anything that you guys think that is important for the public to know? What were you going to say?
Well, I just wanted to say that it's funny that you say that it was the most terrifying thing to get to talk to general public, not your peers, about it. I had a moment of that. I wasn't exactly science communicating, but it was Christmas. I was around Christmas table, and then my aunt cuts across the table and says like, "So Margot, explain what you do, and do you earn money from this?" So I was trying to explain to people who really are not scientists, they're not artists, about what I do. And then I realized that I need to be careful of how I use jargon, a lot of my communication about what I do relies on people knowing a lot of things, some background knowledge, which my family didn't. So it was a bit of a struggle. So I changed the subject.
Well, is it, what is jargon? Do we all fully really understand what jargon is when we're telling someone? I think that's maybe jargon is relative, and when you get very deep in an area, can we tell what jargon is easily?
No, I mean, I think when I'm in the middle of the table, I'm continually asking people, what do they mean? Because people don't want to admit they don't know. Come and join us. Do you know everything, or are you here to learn? That's what we're talking about at the moment. And for me, I really liked your kind of intro onto Talkaoke, because you started off saying, I'm researching aging, but I don't know what aging is. And as an artist, it's very important to sort of do things that you don't know. And it's the same as a scientist, and I think this is the heart of creativity. It's about not knowing, because if you knew it, then you'd be kind of, you'd be there already, and clearly we're not there. But it's very hard for people to say, I don't know, because it makes you look like a dumbass. Like, I was watching Rick and Morty last night. Rick never says, I don't know, or very rarely. And that's the kind of model of the scientists we've got, that they know everything, but actually, if they did that, then they wouldn't be very good scientists.
So we're talking about the paradox of being able to think that you know everything, but also be able to say that you don't know anything. We've got some new people at the table. We're going to start from the beginning with names. Welcome to the People's Talk Show, where we talk about what you want to talk about. What is your name?
Mikey.
Mikey.
Brad.
Brad.
I'm Shashank.
Shashan.
I'm Margot.
Margot, nice. And I'm Lucy. Welcome to the People's Talk Show. So we're talking about the parallel between, do we know what we're talking about, do we not? What brought you here today, and do you feel like you know a lot about it?
Absolutely not. So I'm an undergraduate student, and I'm really keen on bioinformatics, and I heard the word dragon being thrown around a bit. I recently worked with the dragon VCF calls, and I had absolutely no idea what any of those were, so I was just kind of fumbling around. I got interested.
Yeah. So you've just said we've got someone new at the table, so we're going to just do a little intro. But you mentioned something to do with dragons, and I personally don't know what that is. So just give us. So we're going to do a round of names one more time.
Mikey.
Mikey.
Brad.
Brad.
Shashank.
Shashan.
I'm Margot.
Margot.
Tomilola.
Tomilola. Great, amazing. Do you know what Dragon Q?
Sorry, there's a dragon as a system of variant calls, so for VCF calls.
One more. So we were just actually talking about what is jargon, and I may think, I think dragon SQLs is jargon. Maybe if you had to explain that to people that don't know what it is, what is dragon something something?
I would like to know, but essentially, from what I understand, so these things called VCF files, which are essentially ways to notate how the differences between people's genomes, specifically for specific genes, and Dragon happens to be one software that does it, is I think what it is. I don't know. I've only worked with it over like a 2-week internship, so.
Okay, amazing. So it's a software that helps you look at DNA and genomes and tell the difference between them. It sounds like they're a software, and it sounds like they might even possibly be in this room. It sounds like the type of people that might have a little stall. Do you know what Dragon is?
I haven't used it before, but I'm keen to learn.
So you have heard of it. And so what do you do? What brought you to this table? We were talking about whether we know a lot about
what we know? Can we feel like we can say we don't know that much? What brought you here?
I'm just going around and grabbing, being a sponge and absorbing stuff. I teach a group of learners who are thinking of going into vet nursing and vet medicine. So my role is educating them in cell biology and genetics. So all DNA-based stuff, and that's what brought me here today. So I'm just meeting new faces and making connections, networking, which is good.
Nice. So we were in this phase of Talkaoke, which is the People's Talk Show. You can choose what to talk about. However, we do have a light theme of science, communication, and creativity. So if you are a teacher, probably working in some form of being able to explain things accessibly, understand what jargon is, do you feel like you're able to do that? Do you think you have anything to share with the room of people who feel like they are afraid to say they don't know what they're talking about?
Teaching is amazing because when you teach, you have to learn to teach, and understanding the individual needs and personalities of your audience is key. So it's nice to know everyone and to be able to make that connection. Yeah, thank you.
Amazing. So being able to understand that everyone is different, we talked about that a little bit earlier, is that all of our data, we are all different, especially when we analyze all of our data and we're trying to understand that. Have you got something you want to say?
I was just thinking about it because we bring Talkaoke to different places. I think we were in a science museum last year or something, and it was interesting because there's obviously a lot of people very knowledgeable about science, and then there were people who were knowledgeable about science but also maybe not believing in evolution and stuff like that. And then I think that's sometimes very hard to kind of find that bridge between what you know are facts or what you think you know are facts, or maybe you know facts. Is there any certainty around facts these days? I mean, who knows? And how to kind of convey, or how to strike up a conversation when you know that maybe on some fundamentals you have a lot of differences with the person you're speaking to. So it was an interesting Talkaoke, I have to say, but at first it can be a bit overwhelming.
Interesting. We've now bridged into knowledge differences, our personal differences. It feels maybe it's a big topic at the moment behind everything. Did you have something you wanted to say?
I think you nailed it with that point around facts, because we were talking before about scientists and knowing things and not knowing things. And the worst is when you're trying to explain a point to someone and trying to get that balance right about what we know and what we don't know, what's certain and what's uncertain. And one of the hardest things I find when I'm talking to the public about a contentious topic is getting the balance of uncertainty right. Because if you're on social media or a platform and say, here is the answer, then people listen. But if you go out there and say, well, probably, people don't. But that's the most honest answer at times. And science is the whole thing about not knowing the answer, so sometimes we're wrong. But the voice that is the most authoritative sounding sometimes gets the most elevation. And that's a real hard thing I find when I'm balancing that exact problem in a public science forum. Absolutely.
Amazing. So saying and sounding like that you know what you're talking about can give you authority, but it actually maybe doesn't allow for the space for truth, maybe, that we don't know what is true.
But also I think the way that brains work by and large is that you start off with the things you know, and it's like a Lego thing that you can, if you try and introduce something that doesn't fit with what you know already, it's very hard to integrate that. So you need, the way people learn is that it needs to be based on what you know. So people might know things that are not from, let's say, from a science field, but you have to sort of like build from what you've got, not build from what you know. So we call it in the people speak, building the bridge from the other side. But that means building on the knowledge that may not be science knowledge. It might be like narrative knowledge or cultural knowledge, but you still have to build from that side.
Nice. So how do we make the information we're trying to tell people relate to their own lives? If it's complex science, do you have something you want to say on that?
I was just going to say thank you so much for this opportunity. Are you about to go? I am indeed.
We like to ask for a final thought if you're going to go, so can you leave us with a final thought?
You're all amazing. Keep being the best versions of yourselves. And amazing to meet you. Thank you.
Thank you so much. Round of applause. Thank you. Amazing. Okay, so how do we make things link, sometimes completely different topics linked to people's own lives?
I might have a dash in a moment as well because of a workshop, but I would say I was really interested in what you said about the Lego bricks analogy, where I think we can be more comfortable, even in the general public, because I'm not that different from the general public right now, for having two ideas that do not fit together and being comfortable with that. I mean, in some sense, it's cognitive dissonance, but I think that can go in a long way in that you can have contradicting ideas and they'll make sense eventually, but we all don't have the resources or the time or the access to find out why those two are consistent with each other. There are people that don't believe in evolution, or there are people who believe in the flat earth theory, and it sounds abysmal, but when I'm engaged with a lot of these people, there's a genuine desire that what I see is not what this idea links up with, and so I want to know more about it. And we often ridicule them, which kind of puts them off even more, which I feel like is going back against the idea of getting them comfortable with having two ideas that don't make sense together and then trying to work from there.
Nice, amazing, thank you so much. So that was a really good...
I just wanted to say, yeah, one of the things is, we come across this all the time in Talkaoke, where, the number of times people go, evolution's just a theory, right? Something like that. It's just all the time. But yes, you can sort of kind of flatly deny what they're saying, but I think with both examples, the flat earth and the creationist theory, that's people that are actually thinking about it. So that actually, they're on your side because they're thinking about it. They are thinking, okay, how does this world work? How did we get here? All the big questions, what shape is our planet? All of these things, they're actually thinking about it. So I think it's a really good starting point. And, some of the evidence they've got supports, let's say, the flat earth theory, because look, this XL center looks quite flat. It doesn't look curved. So what is that going? So there's lots of, I think we tend to sort of be very confrontational instead of collaborative in some of these discussions.
Okay, so we've covered topics to do with, so that was your final thought. Let's give you a round of applause. Amazing. We've kind of headed into psychology about communication. So how can we hold two truths that maybe we feel like are false or different to our own? How can we communicate something complex that maybe doesn't necessarily relate to people's lives? How does genomics relate to people's lives that maybe they think it doesn't?
Yeah, well, I would like to find out how genomics relates to my life, but come and join us if you like. But I was just wondering about this this idea of commanding authority. I saw a video online, and where a person was talking about the micro mic, and how when you hold a mic, you could be talking. I mean, it's a symbol. I'm holding a mic right now. But it's a symbol of some kind of authority, and even though what I'm saying may not be absolute fact, so it doesn't even have to make sense, but it may be really entertaining or whatever, it doesn't matter. But visually, for people, when you're holding a mic, that represents some kind of authority, and size doesn't matter when it comes to a mic, because apparently micro mics are okay as well.
So yeah, what happens when you give someone a mic? Does that mean that they can communicate better? Does it mean that they can communicate worse? Do they like the sound of their own voice? Does this mean that anyone else wants to speak into the mic at this point and share something that is truthful or something we don't know to be truthful? What do we think the power of genomics is for the public today? How can we communicate that clearly to everyone?
I mean, I don't know. I sometimes wonder whether it's about having a very simple message. I mean, this is not a field of genomics because it's just not my field, but, people that for example, there's this guy called Gary Stevenson. He talks, I'm sure he's a very clever guy and he can talk about lots of different things, but his kind of main message is tax the rich. And every time you listen to him, the one thing that you can rely on is that he'll say that and he'll go into detail and he'll go over it again and again and again. So even if you don't know anything about anything, you'll remember that this person is repeating, what's your message to the world right now? Is it tax the rich? Is it genome for everyone? I don't know. But yeah, that's what I'm saying. Simplify a message, and if you say it enough times, people will start. Because as the guy was saying, there's a lot of noise. We all need to be carrying these little bins. So simplify, I think.
So how can we distill a message? Does anyone have any message that they want to distill about genomics? What is the message? Is that the right thing to do, to really oversimplify something, to communicate it?
Well, when you've got the human genome and it's 3 billion base pairs, it's quite hard to simplify that. Do you know what I mean? And that's, I think, the problem why genomics you know, and we had Maria over here as a mathematician, data hungry. But most people, as soon as you say maths, they just glaze over. As soon as you, even basic maths, you know, like, you know, I earn £2,000 a month, how much do I earn a year, kind of thing. People just like, so, yes, you can simplify, but you obviously you lose a lot of the nuance and the quality in that.
You say you just said, Mikey here just said that when people glaze over when it comes to numbers, and then use the example of salary and money. And do we actually feel people glaze over when we start to talk about money? I think are we actually, that's the only way we can take numbers in, is when we think about it with a dollar sign on it. What do you think your single message is that you want to communicate about? If you had to distill one thing down that you were here today to tell everyone about genomics, and you were going to do it clearly, what is that you'd say? Welcome to the People's Talk Show. We talk about what you want to talk about, but we are talking about how we communicate clearly. Hi, so welcome. What's your name? We've got everyone at the table.
Ben Owen.
And we've got Ben Owen. We've got Margot. Sorry. We've got Mikey.
Mikey Winecoat.
We've got
Brad Elliott.
Thank you, Brad Elliott. Amazing. What's the message that? Oh, and my name is Lucy Brown. What is the message that you want to maybe? We were talking about how we can communicate clearly. We're here sometimes with quite complex topics. Talked about whether we can distill it down. What is the thing that makes people listen? How do we make it relate to their own experiences? But did you something brought you to sit down at the table about communicating? What was that?
Just understanding, better ways to do things. We are a progressive company that wants to improve science and bring down some of those barriers and some of those challenges in the lab. So we're just sort of working on that and seeing that.
What are those challenges?
From our perspective, a lot of issues around throughput and lack of automation and single shot analysis, where we can do multiple things at once, basically.
Amazing. Single shot analysis of what you've said a lot, but maybe could say more of what? What are you putting through? Tell us. What are people looking for if they're using your equipment?
They are generally trying to quantify levels of nucleic acid. So they want to see how much DNA or RNA is within a sample quickly and easily, and we help with that.
Nice. Okay, how about you? Is there any one message in terms of communicating you can add to that? If you're trying to give a message really clearly, what is that?
Oh my God.
Nucleic acid. Do you think everyone knows what nucleic acid is? Everyone in this room, would you say they would clearly understand what nucleic acid is?
Probably as much as I do. Ben's the sciencey one.
Yeah, we have a whole range of voices in this room, and being able to communicate. Not everybody knows what the same thing is. We've had lots of people at this table. We've had lots of different words and jargon, and I think the one thing we've agreed on is that there's so many different types of jargon, and what we understand to be jargon isn't jargon for someone else. What's your name? You're new at the table.
My name's Douglas.
Hi, Douglas. Welcome to the table. What brought you to sit down to the table? Did you have something you wanted to say that we were talking about?
Well, I'm intrigued about what you guys are doing. So in terms of what I have to say will depend on what you ask me.
That's very good, and what we ask you depends on what you want to say. So we're in a cycle. But we're here to talk about, we're at the Festival of Genomics, we're the People's Talk Show. We were talking about how we can communicate messages clearly. We've moved from lots of different topics, but we've got two possible hands up here to say something, so we'll come see if that guides the conversation a little more.
First of all, I thought I had more coffee than I have because my cup was quite heavy. But what I wanted to say, because we were talking about science communication lightly, and we do that a lot with Talkaoke, but there's a question of simplifying. And for example, you just said a bunch of things which I didn't understand because I'm not a scientist, but but I was just wondering to what. It's a good question. I think somebody posed earlier, like to what extent are you able to simplify so the layperson on the street can understand, and at what point do you need to start educating? Is there pressure if you're a scientist to educate as well as engage in a conversation? Are they two mutually exclusive things? I wonder.
Nice, amazing. So the balance of being able to explain something, is that education or is it just explaining, being clear about what you're saying?
Well, now I know what I can respond to.
Amazing.
I think it's important nowadays for us to have good...
Before you go, we like to take people's final thoughts. Well, give your final thought before you go. Go on, final thought. Sorry.
I think these open dialogue things are impressive, and it all helps everyone, and it'll get there in the end.
Amazing. Round of applause. Thank you very much. Sorry, as you were.
And added to that, I think, yes, we need to have a world where we can allow everybody access to information, which we have. But access to information doesn't mean understanding information. So we should really break down what is needed. As an example, when we had COVID, there was an introduction of a new type of vaccine. And what that vaccine did, it used new technologies that were really, that used nucleic acids, which were the little building blocks in the human body, and how they're controlled. And breaking down those barriers means that people, access to those things is much better. An understanding of what genomics does and plays, the role genomics plays in our lives, as well, is very important in the developing world. For instance, in Africa, there's a big increase in the use of biotechnology in farming. How? Different soils will allow different things to grow in them differently. And I'm not talking about the plants, I'm talking about the bacteria that actually grow around the soils. And so understanding what things on a basic level can improve things. So for instance, somebody might decide to plant peanuts next to a particular plant. Why? Well, we know that it does certain things, but it helps to enhance the growth of certain types of bacteria. And so that kind of information is really, really important. Yeah, so I think it's important to break down the barriers.
Amazing. That was a whole set of very clearly communicated information from Douglas, which is just because we have more information doesn't mean that we understand it, but also we are at a time where information is much more readily available, and if we have the ability to understand it more, we can have greater impact. Is there anyone think that would they disagree with that everyone who has access to information understands it? It does.
I definitely don't disagree with anything that you said, but you mentioned in times of COVID, and I think, you know, there was like a whole kind of, there was a big campaign to educate the public about certain thing which was happening in the backdrop of a massive emergency as well. So everybody had a stake at finding out more about it. But then quickly in that process, there was enough oxygen for like misinformation to develop, or people who maybe interpreted the findings in a different way. And I just wonder, like, what's the kind of single origin of that? Is there a single origin of, you know, of how misinformation is kind of, how it originates as well?
So what are the sources of misinformation? Why do we get information? Is there power from misinformation, from the people communicating it?
I mean, I think one of the things that happened during COVID is there was a huge dissonance between the public health message, which, as you were saying earlier, Brad, has to be confident and authoritative, stay at home, you know, and all of these kind of things like wear a mask and get a vaccine. But science actually isn't like that. Science is much more discursive, and people have got different theories, and that's the kind of absolute amazingness and what people have got excited on earlier on today about the discussion and the different possibilities. But that's so different from public health messaging, which has to be so, you know, exact and authoritative. And I think actually a lot of the misinformation comes from that dissonance between those two positions.
So we've kind of taken a whole journey on why does misinformation happen? We do have access to a lot of information. Is it because for people to accept something as truth, they need to hear it come across as clearly? And actually, in science, there is nuance, and there is stuff that we don't know, which means that if we say that we don't know, it means that people don't listen. Is there a cycle that happens, that the kind of clearer that we try to be, the maybe further we get from the truth? Is that what we think is happening? Is there a way to work around this, maybe, if that is what's happening? Do we have any thoughts at the table?
So I think the COVID example is a really good one, and the wearing the mask one's a great one. Because if handled right, nuance can be okay. I distinctly remember the really early days of COVID being the public messaging being, don't use homemade masks because they don't work. And I remember being part of that conversation at the time. And then it evolved into, well, maybe they do work, into that became the message, make a mask and here's how. So we can do nuance, I think, if we do it right. And it's really hard. I don't know the answer to that. But the other thing about the COVID one I thought was a good point was, when we focused our minds, like that focused us on a problem. It was a big thing, it was very obvious and apparent. One of the things looking around this room today is a lot of the work going, a lot of the research going, a lot of things we've talked about are future ideas or future problems or future things that we don't yet know about. And so we don't have the focus right now to say why all this stuff is so cool and so interesting. So I thought I might kind of throw that out there as a challenge or a question.
Amazing, awesome. Thank you so much. We've got a new person at the table, so we're going to do a swing round of names. So we'll start over here.
I'm Margot, hi.
Margot.
Mikey.
Mikey.
Brad.
Brad.
William.
Welcome, William, to the table. Also, we're going to have one more new person while we're doing intros. You want to come join us? And
Douglas.
Douglas and I'm Lucy. Welcome to the People's Talk Show. Thank you so much for joining us. We've gone through a bit of a journey. We're talking about misinformation. We're talking about how can we communicate messages clearly. The clearer that we are, maybe that people have to understand the message. We have to be clear. We have to give authority, but then maybe there's no space for nuance. Then also we came up through a question Bradley raised that we actually can communicate nuance, but we have to do that carefully. But what is that way to do it carefully? How do we communicate? Sometimes, like, science isn't one clear message always. It's got some complexity to it. How do we bring people with us? What type of information do they need to know first? How do we communicate nuance?
I mean, your plants example, Douglas, is really growing on me. And what I wanted to say is just made me think of sometimes. Thank you. No, but it's sometimes it's about. If somebody's interested in a particular subject, and for example you said, if you plant this type of plant next to this other one, there may be a real reason why that's a good thing. So if I'm interested in growing whatever it is, then I would be interested in this kind of information. And I think for me, I was just thinking about it, it's about finding relevance or linked to my own interest. Like, for instance, I realized in my recent blood test that my iron levels were very low. So that was my interest. Like, before, I didn't really care. It was just not on my radar at all. And I'm like, I know that I have to drink coffee only 2 hours after I had something with iron, and also I have to eat something with vitamin C. So all that kind of stuff. But I wouldn't be interested in it. I'm not saying this is like complex science, by the way. I'm not claiming this is the case. But that was my kind of starting point to get a bit more information, get more interested in that subject. But I wonder whether it's possible to show relevance of everything that goes on here in the world of genomics to an ordinary person.
Yeah, so you saw the relevance to something that may have, to anyone else, not be so relevant because you could see how it related to your own life. Mikey, did you have something you wanted to add to that? You had something you wanted to say?
No, I just wanted to say I agree with what you're saying. I think, I don't know what the phrase is in Latin, know thyself. I feel like everyone wants to know ourselves. And if we can get like a little piece of information that shows us a little bit about who we are, then that does, as humans, we're self-interested in it. That's just a part of us, innit, really and truly. We all started as a sperm and an egg, and we all done that journey by ourselves, and we're all still trying to get to know who we are, I think. That's always going to be in life, so yeah, that's what I'll just say.
Nice. So we want to know more about ourselves. If we can make it relate to ourselves, we're interested. Would you say that?
I would agree with that completely. We need to know more about ourselves, more about the environment. Now, the Festival of Genomics is is opening up this dialogue and this debate about, where does genomics fit in with our lives? And then it makes people more interested in drilling down for their specific interests. So I think it's good that we have festivals, genomics like this, where we can begin to talk about it. But we have to remember that there's a particular way in science that deals with specifics. And those specifics, as a scientist thinks, are, this is what I want to test for this particular area, and these are the results I've determined. I've published them, and this is accepted fact. How that fact then fits into a wider area is a different method altogether. And it's how we negotiate that knowledge base is the interesting part that we're actually getting to now. And how we use the information. How do we draw it down for specifically my iron levels or my nitrogen next to my plants or COVID. It depends, and it's a really exciting area where things are coming together. But on that one, I just have to say this is a really, really wonderful opportunity to share ideas, share thoughts, and I must leave you all and go and continue my communication to my customers.
Amazing, that final thoughts. Thank you, Douglas. So that was our science. When we publish it in a small scale, the real interest comes from that wider application. We have a new person at the table, so we say goodbye to Douglas and we say hello to...
Just listening. Hi, I'm Paul.
Hi, Paul. So we're going to do a new re-intro. So we've got Paul, we've got Margot, we've got Mikey, we've got Bradley, and we've got William. Okay, so when we're talking about our hand, we've got me, of course. My self-interest, it's me. When we're talking about our self-interest, let's check in, because I think we've known a little bit. We know that Bradley's working on aging. What are you working on, William?
I'm working on IBO. Basically, that's a research study, stands for Improving Black Health Outcomes. I've kind of just started. I don't want to let thingy, but basically I'm a research assistant. I'm not no one big or nothing like that. I just saw you guys just being pretty excited.
No, this is awesome. No, we are all, everyone's important at this table, and everyone has all their own different information to bring to us. So that's so interesting. So say what IBO stands for again.
It stands for Improving Black Health Outcomes. The reason that they started this in the UK is because historically black health outcomes hasn't always been the same, and one of the reasons what they're looking into is because of lack of data. Most of the data is done for European white males, so it's just catered towards them, like obviously we're in the UK and things like that, but they're just trying to kind of close those gaps between the discrepancies in healthcare. So what their aim is, I think, is 10,000 black people from the UK to provide a saliva or blood sample. What they'll do with that, don't quote me, you might have to look on the actual website, but I believe it's whole genome sequencing when they're going to look at, or part maybe, something like that. So I haven't actually seen the labs yet, but what I assume they kind of look at each data and kind of do their magic and things like that. But I'll just say one last thing, it's also it could be someone from any health, so you could have you could be someone totally healthy, or someone that's going through ailments, so loads of different degrees of health. It's not specific, they're just trying to guess.
Amazing. So it sounds like a much needed area of work to improving black health outcomes. And for that, it sounds like you're going to have to work with a lot of people, bring a lot of people in and communicate that to a lot of people. So we were talking about how we can improve communicating, or how do we bring people in on that messaging? Is there anything in your work that you think that your team, if you're kind of new to the area, anything in terms of communicating to different communities, there are any nuances or difficulties there?
There's nuances, because with for example, certain cultures taking blood and things like that, blood is spiritually, has a spiritual significance and things like that. But yeah, I'll think a little bit more. I think the two other if you want to say something.
That's so interesting that different cultural differences can mean completely different things, and then can have different things for health data, and therefore implications for people's health long term.
I mean, you just reminded me of a Talkaoke we did with Imperial College, and their research there was around indoor pollution. So really, I mean, yeah, it was like that. But then we were doing it in West London, and a lot of people who were around the table, from different backgrounds, they were saying that, actually, if you want to engage us in any research, you need to just be cognizant of the fact there's a lot of mistrust, and particularly communities of color, because of how science was done, and how people were maybe used to kind of obtain some kind of samples and kind of instrumentalized. So I think that's one thing that was kind of coming out there as well, is just that different degrees of trust, which, it was definitely something that I've learned back then.
So we've just done a lot of conversations. All of today we've just been talking about data in quite an objective way. Can we want to have data, use data, it'll help us see things, but actually where we get that data, how we collect it, is by people, and often has been on people, maybe without their consent, and it's actually got a huge social element to it. Any thoughts on, I think we had Mikey first.
No, that's pretty much what I was going to say, what he just said. But yeah, this is the thing, is there is an institution of science which wants to be neutral, but it isn't neutral, and it has got a colonial past. And I was at that Talkaoke as well, and people just didn't trust the institution, definitely didn't trust the government, and probably rightly so. So there's two separate subjects there, but they're interlinked. How much do you trust the government, or trust you? We were talking earlier on about public health advice. People didn't necessarily trust it because they've been, abused in the past.
So we're talking about communicating in public messages about health, and is that easy? And we've actually got a lot of work to do to maybe right the wrongs that have been done previously in the healthcare sector of testing on people without their consent, a loss of trust to different communities about health. Brad, do you have something to say?
So you were talking about authority earlier, and I'm a white male scientist, and I am the picture of how science historically, and I get that, right? And I'm aware of that now. But you raised that really good point before, that we're missing a lot of data. And there's a joke in AI that models are only as good as the data that goes into them. And if you don't put data into a model, then from the model's point of view, the data doesn't exist. It's not that it's missing, it just doesn't exist. I remember being shocked. A friend of mine, who we're going to talk about later, I'm going to definitely introduce you to him later on, doing a lot of work around genomics and just filling in the gaps, basically, just equalizing the data sets in the background. And he told me some statistics that I can't quote, I'll get it wrong, but it's like in the regions of 80 to 90% of data sets is white European males. And I remember saying something like, oh, I'm shocked by this. And then he looked at me and said, I'm shocked, you're shocked. You should know better, you know? And it was a really good line. So it's something I've become very aware of. And it is absolutely, like, just almost an ignorance of background where we come from.
Yeah, that's great, and that's very interesting about maybe a line of shame in terms of communicating something that people should know or it shouldn't know. What's the power in that? Should people? I think that's really interesting. All day we've been talking about information, data, and this is possibly the first time that we've talked about the gaps in the information and that having a social colonial history. We've had some voices here saying that they should have known better, but we've got every person has a chance to learn and a chance to find out new information.
I mean, quite often when we do Talkaoke, we visualize the conversation, and we do it in lots of different places, and quite often it's science outreach. And the way we do it is we just pull images from Google, other search engines are available, and quickly, collage them. But if you type into Google Images, scientist or doctor or mathematician, and you get a picture of something very cliched, but it's always a white person. It's like you have to type in black doctor or Indian doctor to get a doctor that's not white. And because Google is reflecting a kind of cultural bias there. Scientists as well. When you type in scientists, you get someone that looks like me, like normally Einstein. But there's lots of different appearances for scientists.
So we've kind of talked about how we've. Oh, yeah.
Oh, sorry. No, I just wanted to say, because earlier you mentioned something about nuances and how you can communicate. Like one of the things that I try to do, I try to be as transparent as possible to the person, because I feel like people just want to know kind of what's going on with their blood. Like I could say, okay, your blood sample is going to here. There's a lab in Milton Keynes. That's where it's going. And I think the more information that people have and just kind of like be transparent with them, it helps. And I can understand it can be a bit annoying because these people aren't scientists. So if you're as a scientist speak to someone that's a non-scientist, you might be thinking, why are you not interested in this? Why are you not wanting to take part? But I think someone mentioned earlier, they just don't understand. I think it goes back to the self-interest thing as well. But yeah, that's what.
Yeah, so a way to communicate clearly is maybe transparency. So that's one of those, something that can maybe help is being truly transparent, is because people can tell maybe that when information is being hidden.
We've always got this concept that people speak called building the bridge from the other side, where we, instead of saying, right, we've got all this science, we want to tell you about this science, have you heard about the new science of genomics? We won't do that. We will just find out what people are interested in and use our creativity to make any kind of science relevant to what they're interested in, what they want, what their life is all about. Rather than saying, right, this is relevant because we say it's relevant, it's better to find out what is interesting, what are your aspirations, what do you want in your life, what are your problems, and then link the science to that.
So we've got one way, so communicating through transparency, how can we make things accessible and clear? Transparency, we've also got it making relate to people's own lives. There's also some concepts around whether people feel like that information is for them, so they have their own interests, but what about everything that's led them in their life up to that point that tells them whether that science is for them, genomics is for them? What do you think, Margot?
Yeah, I think, well, final thought on it. No, it's just my mum is always really funny when it comes to like latest things, and I sometimes think like, oh, this is definitely not for my mum. This is like, she's not a recipient of this kind of information. But I think sometimes the content, the form in which information is conveyed can put ideas in our heads, so it may not seem relevant, but it's just the way how you do it. So I think social media is very good at that. Whether it's accurate, that's another question. But I think we live in a world where everything has to be kind of like almost entertaining. I think entertainment, it has to be like the go-to, the kind of main reason why people pick new things.
Oh, we do. Before you go, we do a final thought. Would you like to give us your final thought, William?
I think that as we go forward in time, I believe that it is improving. I know there's like little hiccups and things like that, but it just takes a bit of time and a bit of effort, a bit of patience, but we're all going to get there sooner or later. Just like we got here with the sperm and the egg.
Amazing! Positivity from William. We're going to get there. There are hiccups, there are massive gaps in data, but we'll get there. We'll fill them, we'll find those gaps. So we've got, in terms of how we can communicate, we've got transparency, we've got, what did you say? You said we had transparency, we had authority, clarity. How can we communicate genomics clearly? We make it relate to people's own lives. We make it entertaining. That can make it relevant to them. What do you think, Mikey?
I mean, I don't really think entertainment is a separate thing. I think it's just like, it's really just engaging people. So, like, I don't think to say, oh, this is entertainment, therefore it's not important or it's not good science. To me, it's just about the mode of delivery. But just coming to the sperm and the egg, I was thinking, yes, that's something everyone's got in common. But now you've got people that are created from 3 parents. So that is an advance, isn't it? Yeah, you've got people created from 3 parents, like a sperm, an egg nucleus, and a egg, the other bit, cytoplasm. So that exists. Mitochondria, exactly, yeah.
Okay, so we've spun around from talking about different ways that we can communicate clearly. What does that mean? What does it mean for it to be engaging? What are the gaps in the data? We've spun around and we've whipped all the way around to 3 parents. So, Margot, do you have something to add to that?
Yeah, but we just, I don't know how worthy that contribution will be, but at the very beginning of today, before we started doing Talkaoke, this guy called George came up to Talkaoke and he said, oh yeah, I'm definitely going to come back because I love science communication. I said, oh yeah. And he said that apparently there's a lot of opportunities for scientists to master the science communication, but it mostly happens through competitions or something like this, right? You know it, right? And he said it's like it's not Fab Lab. What is this? It's like a TED Talk. Fame Lab, there you go. Sounds like Fame Academy back in the day. Do you remember Fame Academy? Anyway, but it almost is requiring people to be always constantly pitching, always be entertaining, engaging as a speaker. And can you really be a good scientist if you're a really great speaker? I mean, is Brian Cox a great scientist? I don't know.
Oh, controversial. You got so many things to say on that, Bradley.
Hi, my name's Dr. Brad Elliott. I'm the London trainer for Fame Lab. Other science competitions are available, and they genuinely are, you're not wrong. So I do lots of science public engagement and communication where I make science entertaining. And there is that perception that if it's funny, it's probably not serious science. But if you can't convey a message that someone will listen to, then you've only done half the job, I think. If people don't know about your science, then your science goes away. It doesn't have any impact on the world. And I can guarantee if you're teaching a room of 400 undergrads or talking to a stranger over the fence, if your science isn't interesting to them, they will give up and walk away. They will give up on you. So you've got to make it interesting in some way, engaging in some way. Some scientists aren't brilliant in science communication. That's okay. Some people are, and that's okay too. But by training people to do it, we can help them pitch their message or pair them up with the right people. Brian Cox is a great example. Great scientist, of course he is. Wonderful at what he does, but an excellent picture of saying, let me tell you why this thing is very deep and meaningful in a beautiful, poetic way. Some of which he wrote himself and some people write lines for him, and that's okay too. But he does it well on camera. And so that means people watch and listen to physics or biology or quantum stuff that they wouldn't hear about. That's brilliant. That's a win to me.
So, is making science sexy right or wrong is the ultimate... Well, do we think... So is part of Brian Cox's appeal, is it just the way he communicates, is it the way he looks? Do we have biases in how we receive information? Is that at the core of whether we'll take something in? What do you think? Is it to do with, what the person looks like, what they're saying, how they're saying it? Is it engaging?
Definitely. I mean, I think, when you're not a scientist, scientists kind of would want to exclude that possibility that the charisma and sexiness is part of the delivery. But as an entertainer or as somebody in the cultural field, that's kind of obvious. It's just so obvious that you wouldn't even dispute it or debate it. But at the same time, as you say, there are scientists that are very bad at communicating or don't want to do. I mean, I'm just thinking we're in the realm of physics again, but the mathematician Paul Dirac was extremely socially phobic to a point where he wouldn't even he wouldn't talk to his peers, but he discovered the antimatter, so so there are people out there as well that need someone else to do the communicating for them.
So how do we communicate something well? What is core to communicating something well? Do you have to be doing the communicating? If you're a good communicator, do you have to do the science? Do scientists have to communicate? Welcome to the table. So we'll do names. If you'd like to join us at our table, the People's Talk Show. We'll start. So we've got Margot. Hi, I'm Margot. We've got Mikey.
Yes, Mikey, yes.
We've got Bradley.
Hi.
And what's your name?
My name's Abida.
Abida, welcome, and my name's Lucy, and this is the People's Talk Show, where we talk about anything you want to talk about, but we are here at the Genomics conference, so everything is swayed towards science and genomics. We've just been talking about how do you communicate things clearly, how do we communicate nuance, how do we bring people on side. We've had Brian Cox. Does everything have to be sexy when you're communicating science? Does that give the message a clear steer? What do you think?
Are you talking about in terms of giving maybe demos to attract certain customers, show them how the product works?
Yeah, what do you think? It sounds like you're coming maybe from a product background. How would you want to explain something clearly and accessibly? What would your go-to route be to make sure that you're doing that?
Probably obviously have a live demo, show them for example, I work in AI and data, so I'd probably show how the model runs, maybe show a bit of how the code works behind, and maybe also show, so I've done image analysis and stuff before, so maybe show them the predictions from what your image you're inputting, and then how the AI is using that image to make a prediction image.
Amazing. So you use really clear examples to show people in practice. We've talked a lot about how you can explain how it relates to people's own lives or their self-interest. Does that come into your pitch? How can you make that relatable to the person that's in front of you?
Sorry, could you repeat that?
So we've talked a lot about, when we think about genomics, everyone wants to know about themselves. So, why should I care about the amount of iron I need? And then you suddenly get a blood test and you find out that you're anemic, and suddenly that all becomes really important to you. So when you're explaining something to someone, you want to make it accessible to them, relate to them and why they need this tool or why they need to know this information. Does that come into the way that you would explain something, making it relate to that person specifically?
Yeah, would in terms of for example, patient getting results, you would want to kind of show them how to, for example, you're anemic, you found out you're anemic, you want to maybe show them what medicines and maybe what natural how to naturally kind of, sorry, I'm so bad at explaining. No, kind of like maybe natural fixes. So some people might be kind of against like medicine and stuff, but maybe show them like how to fix yourself naturally, like make stuff at home, or kind of also maybe show online, like maybe do like exercises and kind of show some way.
Amazing, thank you. So there are lots of different ways that we can communicate information, but also think about our own health. And you've talked about we've got traditional clinical medicine. We've also got more traditional medicine that you can do at home. Different exercises. Do we think we've got different ways to tailor information to everyone? So we've got these 3 different ways. Any more ways? Anyone think that doesn't work? Doing it like that?
No, I mean the opposite really. I mean my brother is a scientist who studies worms, and he's got a worm dance, which is a worm dance. Yeah, he's got a worm dance. So that, yeah, it's a bit. Have you seen the worm dance? Maybe you have. So I think it's just about being creative. I think that's the thing. I mean, obviously this was what this is themed around, but. When it comes to science communication, in a way, and it's something that we experience on Talkaoke as well, the more creative it is, the more people will just absorb that information. So, Leah, let's do a dance. I don't know what the aging dance would be, but, you know, maybe that's something to think about.
I guess we're here talking about interdisciplinarity to communicate messages. So we're talking about, do we want to use dance? Do we want to use music? If we were to musically communicate what genomics is, what would that sound like? Would it be techno? Would it be jazz? How would we like to communicate these messages?
I think it would be an incredibly vast symphony using only 4 notes.
A vast symphony using 4 notes. How would that sound? Anyone want to add to how they would communicate using music? Anyone think that there's a better way to be able to bring people in and be creative? Anyone want to come join us at the table? We can also talk about anything that you want to talk about. We've been talking about how to communicate information accessibly. This is the People's Talk Show. We talk about what you want to talk about. What would you like to talk about, Bradley?
How horrible I am at dance and music, so I'm not going down that rabbit hole personally. One of the key things I've learned really quickly is that not everything works for everyone. So that, like, sometimes some audiences that will be great. Sometimes music will be wonderful, sometimes plays, or I've done a puppet show before for kids. That was fantastic. So what creativity means, like exactly what you say, different messages for different people. And one day it's a message for policymakers and law writers, and one day it's a message for school kids, or a room full of thousands of genomic scientists and AI scientists, trying to get them involved.
Nice, amazing. So from puppet shows to policymakers, we can communicate things and make it accessible to everyone. What do you have to say about that, Margot?
I mean, I like the idea that maybe you'd have to communicate. You're essentially telling a story, right? But just to different audiences. But I wonder how many overlaps there are between telling a story through puppet theatre to children and telling maybe similar story to policymakers. I mean, I'm just interested in that because, yeah, I mean, are we just talking about things that we've got in common as humans apart from, I think maybe majority of us at this table were conceived by 2 parents. That was a conversation from way back. But 3 parents are welcome as well. But maybe the other thing that we have in common is that, you know, we all like to hear a good story, and maybe, you know, simplicity of a story or like core messages in a story is something that's, yeah, that's good news for science communication. I don't know what my point is, I'm just getting distracted by nuts being passed around.
I think we've got one more to add to the tick list of how to communicate things clearly. We've got transparency, we've got authority, and we have storytelling. What do you have to say about that, Mikey?
I mean, just riffing off the puppet show, what about Genomics, the musical? I think next year we need to make it a challenge that we've got that ready and produced. Genomics, the musical. And how is it going to be? Who's going to be the villain? Are the proteomics people going to be the baddies? How's it going to work?
Okay, we're going to workshop this right here, right now. Genomics the musical. What is an essential component, that is part of a West End musical if it was about genomics? If you'd like to tell us, come take a seat. Tell us what is essential if we made a musical about genomics. So we need a plot, we need melodies, we need main characters, we need villains, we need a story arc. Anyone want to give us some of those? I'm not sure what this noise is, but we'll work through it. Oh, it's that phone. Anyone have ideas about if we were to make a musical, a West End sellout about genomics? What would that be? Go on. Main character will be called?
I'm not sure. I'm like very AI and data based, so I don't have very much knowledge on like genomics. I've just recently worked. So I've just recently got into like the bio and chem side of my project. So I'll just be doing like AI and data science in like just normal.
So if AI and data was to come into that musical, maybe that's part of the plot, AI and data?
Would AI be the baddie or the goodie?
What do you think? Is it Adiba? Adiba? Abida, sorry. Abida, would AI be the goodie or the baddie? You make the decision.
That's really complicated. I think...
Unfortunately, it is just a hard and fast line. They can only be good or bad.
Yeah, I'm going to say good side.
Okay, AI is going to be the hero in this story then. If on genomics and AI and data here today, have we got a goodie? We've got the goodie, which is AI, the hero. How about the baddie?
I don't know about the baddie, but I'm kind of thinking like it's quite hard to, I like to think I've got imagination, but maybe to imagine a genomics musical would be a bit hard for me. But I remember watching that film. What was that film about? Stephen Hawking. And in the end, it was about human stories, like how he became maybe it could be a musical about you, how you became interested in what you're interested in, But I think that kind of human relatability I'm quite interested in. And I'm sure there's lots of stuff in that film. What's it called? Something theory of everything? Yeah, theory of everything. I think it potentially already exists. But I'm sure there was lots of stuff there which were just there as kind of, tearjerkers rather than real life. But maybe there weren't. For me, there was not enough sex scenes, that's what I think.
So Margot's key message has also been storytelling. So in this musical, we need a key story about a person and a narrative that we need to really stick to. People like to listen to different stories about how people got into genomics and big data, and can ultimately, through a story, genomics, AI be a hero. In your own life, how has AI been the hero?
So I think we go for some nuance here. What if it starts out as the bad guy, but through a complex character arc becomes the savior in the end? And then we can bring this idea of like just complicated messages and things not being simply black or white or binary, but more complex stories.
Nice, okay. We're adding complexity to the simple task of making a musical about genomics. Mikey, what do you think?
Well, going to Stephen Hawking's idea, he was suffering from a genetic disease, I believe. I think it was genetic anyway. So maybe the main character could be somebody that's trying to overcome some kind of rare genetic disorder, but they need to get together the team to actually make it happen.
So that's an individual themselves with a rare genetic disorder, and they go on the hunt. And how does the AI, where does AI, Margot's got a thought, and then I'd love to know where you think AI could come into the story.
No, but I think that's one of those kind of Hollywood ideas as well, right? Where there's a problem to be solved, and you're assembling the team. I don't think I'm going to finish watching Ready Player One, the film by Steven Spielberg from a few years ago, because I've just lost interest. But there's definitely a trope of the main protagonist and other people kind of becoming his team, who are hunting for this, kind of Easter egg of how to unlock this this virtual world and how to possibly influence it, make it better. So there's definitely that kind of, there's the obstacle, there's the team. But when it comes to genomics, I don't know who should be on this genomics. Is there space for a little artist? I don't know, maybe not.
Okay, so it's a classic story, the tale of oldest time on the hunt of the pursuit of the original thing that can make everything better. We've seen it all before. We're going to just check in here on what AI might be in this story, and then we come back to Mikey.
Well, I think AI would maybe kind of solve the issue, the genetic issue in what Stephen Hawking had. So I think AI would come a lot into play, because back then AI wasn't kind of like there, but now it's more like evolving, and there's a lot of different types of like sectors in AI you can get to, and it would like we could look at like those genetic diseases, we can see what's kind of like causing the problem, and maybe create like some predictive model to kind of help maybe solve.
Amazing. So we've got a bit of a timeline here. So before there wasn't, now there is. Can we make a predictive model? Is that what we're looking? Is that the hunt? It's not the golden ring. It's the predictive model we want.
Well, I mean, obviously it's the hero's journey that we're talking about here, but I'm also thinking about kind of like a Greek type of storyline where normally the mortal asks the gods for something, and the gods give them the thing, but then they find out that that thing that they've got is a curse. So the blessing is also a curse, and maybe it's the same with genetic disorders, that the genetic disorder, like for example, I'm genetically I've got bad genes when it comes to my short-sightedness, incredibly short-sighted, but maybe there's a good side to those genes as well. So maybe the curse has got a blessing or something like that. That could be part of the storyline.
Amazing. We were actually talking a little bit, that came in when we were talking about communicating, is being able to hold two truths or kind of difficult ideas together as one. It sounds like there's this duality here, and that comes into maybe AI, and maybe that will come into our plot for the musical, of like something that is also bad can be good, and something that can also be good can be bad. How will that come in a bit more?
I mean, I'd like to workshop what would be an advantage of being genetically short-sighted. But second thing I want to say, like, you know how in films there's like, I don't know, in Scooby-Doo, I would definitely be the Scooby-Doo character, like the dude that doesn't actually know why they're there. They're just there for the jokes. But I think the purpose of these types of characters is that you know, that's a potential for a science communication right there in the purest form, when you have to explain to a dog what is this plot, like what is this thing that you're trying to solve. You have to explain. So yeah, I'll be the kind of person that you can explain to. I'll be the Scooby-Doo.
So in every story, we need some animal, some character that doesn't know what's going on, so we can explain it to them. Is that animal going to be a dog? Where should we set that character? What animal is that?
Oh, I've gone off piece now, because I was just thinking about having Greek tragedies and two star-crossed lovers, maybe.
Two star-crossed lovers, are those people, or is it genomics and proteomics?
Well, it's going to be science, communication, and educational, so if we have A and T and C and G, then we can name, you know, Agatha and Thomas and maybe Claudia and Gracie, and they can become our star-crossed lovers, but then R&E is going to come in and break up the relationship and then get involved, and it's going to go all horribly wrong.
Amazing. Okay, star-crossed lovers from a genetics front.
So it's a genomics Romeo and Juliet kind of thing. I'd like to you see, there's a lot of versions of Shakespeare, like the drunken Shakespeare, where actors perform whilst getting gradually more drunk. There's the improvised Shakespeare. There's all sorts of different Shakespeares, but I'd like to see the genomics version.
Genomics Shakespeare, what would that look like? Come take it and join us. We're currently working out, if we had a musical about genomics and AI and data, what that would look like. We've got an evil we've got the hero that's going to be AI. We've got the star-crossed lovers that are in genetics. We've got there was something else that I have forgotten, if anyone wants to help me. There was something. We've got the dog that doesn't know anything, that needs to be explained to. Is it a dog? That's the question I wanted to get answered. Is it a dog?
I mean, I'm sure there's a name for a character like that. But, you know, it's always useful in Talkaoke to have somebody that doesn't know anything, so that you can explain the simple things and nobody loses face for not knowing. We're coming back to that question about knowing and not knowing. So, for example, when I'm sitting in the middle of the table, I'll often ask things that I actually know,
just to be that person, the Scooby-Doo character, as you say, that doesn't know what's going on.
So let's just decide on what this animal is. The child that does not know how to ask. Let's pick it.
For me, it has to be a poodle, and it's a dog.
Right, poodle with an amazing hairstyle, kind of like, see, maybe like Mikey's. The poodle. Okay, we've got the poodle that doesn't know how to ask. We've got the star-crossed lovers that are base pairs in genetics. We've got the hero that's AI. One more.
No, I was just thinking maybe this is time to kind of do kind of final thoughts, and maybe this is like an ever-evolving subject, and there's a proposition to anybody around the table to maybe have a go in the middle just to see how it feels for 5 minutes, and then just jump out or crawl under whenever you want to. It's an invitation. But yeah, maybe some final thoughts and swap.
Amazing. So Talkaoke is the people's talk show where we talk about whatever you'd like to talk about. We start with intros and we finish with final thoughts. So we're going to go around. We're going to start with Margot. What are your final thoughts for this morning session here at the Genomics conference?
I will be thinking about the balance between simplifying complex concepts and then how to interweave the education, and is informing people. Is it just like a one golden shot of getting the educational bit in, or is it more like over a longer period of time? Is it just exposure to something over a long period of time?
Amazing. Thank you. Round of applause for Margot, please. Mikey, any final thoughts?
Well, it's something that someone earlier on called Christian said all models are bad, but some are useful. And I think that is something I've never heard before. It's a bit like what we say in democracy. Democracy is the worst system of government imaginable until you try to imagine another one. But yeah, I like this idea of models, but maybe it's not just kind of, when we shouldn't just be talking about language models and mathematical models, but also some of these more creative models as well. Maybe there is some use in creative models for communicating scientific ideas.
Amazing. Round of applause for Mikey. That was some thoughtful stuff. Bradley, final thoughts?
Very simply, I would watch that musical. Let's do it. I would watch that musical. It'd be great.
Amazing. Thank you so much. And final thoughts from you?
Well, this is my first time at the Genomics Festival, and and it has been quite interesting because obviously I just have like an AI and data science background, but it's been really nice to see how different lab equipment works, different areas of like genomics, and I've definitely like learned quite a lot today, so it's been quite a nice morning.
Amazing. Thank you so much. Round of applause. And that's Talkaoke morning session.
So my name's Brad, and we're at Talkaoke today talking about genomics, talking about AI, and just getting people to talk to us. And we've got some people joining us already, which is fantastic, bang on time. So come on in, have a seat, join us, have a seat, join us. We're going to do some round of introductions when we've got everyone seated. So, who are we, and what are we here today? Why don't you say hello?
I'm an undergrad student. I'm a biochemist. Yeah.
And what was your name?
Oh yeah, Kobo.
You gonna take my
District.
Say your name for me one more time. I just missed it. I wasn't even.
It's Kawal. K-A-W-A-L.
Carlo, good to have you. And also with us today, Carlo, we've got.
I'm Margot. Hello.
Mikey.
And my name's Brad, and we're at Talkaoke. So what brings you to Festival of Genomics today?
Just interested in everything related to genomics, that's all.
That's fantastic. I mean, it's so much going on, so many things around, so many booths, so many posters, so many talks, so much things. Have you found anything particularly that you've been amazed by, interested in, or found really exciting?
I'd have to think about this, so give me a while. Maybe go with Margot.
No worries. Let's Margot, what did you find today that was super exciting?
Well, I've been mostly around the Talkaoke table, so the conversation's been kind of like going in different directions. But I just wonder, this in this festival, it's almost like being in a big shopping center where, you know, there's some really like kind of blingy stuff. I guess there'll be all the machines, the really expensive stuff, and then there's like the concept things which are good for your soul, but you know. And I just wonder to what extent this is like a big shopping mall.
Wow, the shopping mall of science. What do we think?
I do agree with her. I mean, there's so much to do here. There are posters, there's the talks. I really like the ones in the biodata stage and all the kiosks here and there. So yeah, there's quite a lot to do, and there's way too much.
That's fantastic. One of the themes we've had going on today has definitely been around communication, around science, around creativity, around how do we pitch our talks, how do we get our audience to listen, to pay attention. Have we seen some examples today already of good or bad talks, or what do we think about that? Or in the background, Margot or even Mikey, what do you think? Margot wants to weigh in.
I mean, we were just before you joined, we were just workshopping an idea of some kind of a film or a musical about genomics, and I think I would watch that. I mean, if you can make it as popular as maybe Oppenheimer, which I haven't seen, by the way. I went to see the Barbie film. I know this is like months ago, right? Yeah, so anyway, but you need to kind of really elevate and make it really big and very popular, get on Netflix or whatever like this, just to kind of get people involved, to popularize some complex concepts of genomics. But for me, there has to be, we were talking, there has to be a love plot, there has to be a dumb dog that needs everything explained to, and this is the way to do successful science communication, I think.
What do you think about that?
I mean, one of the things, you know, I've been thinking, I think it was me that came up with the idea of genomics, the musical, but coming up with the Oppenheimer thing. I mean, Oppenheimer was quite a bad guy, really, because, you know, first of all, he tried to murder his professor when he was a PhD student. It wasn't a good guy, but he was the right guy to design a nuclear bomb, which itself is not that great a thing. However, I'm just wondering if some of the sort of heroes of science are not necessarily the nicest people, but they're people with, like, because they've just got drive and they're single-minded, and that's not necessarily a quality of a nice human being.
As a professor, I hope my students don't try and kill me too often, but I'm pretty sure some of them have wanted to.
I mean, in a world of science and also maybe studying science, is it easy to, you know, is it a common thing to have it in for someone? I mean, is there much antagonism happening in science? Because from the outside, it seems to me like everybody's collaborating. Is there much, I don't know if it's about ego, is it about your idea is so radically different to mine, I want to, like, quote unquote, kill you. Come and join us. What's your radical idea? Do you have one? You don't have to have one. Mine is still revolving around Scooby-Doo. No, but I want, like, you know, in science, like, what are the things that can antagonize you? Like, what's the problem? I think everybody's, like, working on something worthy, like, worth everybody's time. What's their beef in science?
Well, I mean, I think there's like a history of beefs in science. Like, for example, Isaac Newton. Oh, let's just get a final thought.
Yeah. Before we go, we want to get a final thought from everyone today. So, what you've had so far, what are your final thoughts?
I do recommend everyone do Talkaoke. How do you say it? Talkaoke. It's fun.
There you have it. Talkaoke is fun. It is fun in the middle too. Yeah, don't think too. Sorry, you're saying, Mikey.
No, I mean, you know, it goes back to this thing where we're talking about science as a sort of pale, male, stale institution, and that's the way that entitled white men interact with each other can often be quite confrontational, because that's just how they do it. And I think there's a history of beefs in science between different, actually, entitled white men that decided they didn't agree with each other. But that's just that's considered scientific progress in the kind of history of science.
Pale, male, stale. So we use healthy, wealthy, white when I talk about aging and the bias of the groups, but I like that. I'm going to remember that one. From Leibniz and Newton all the way to us today. Conflict drives progress sometimes, and sometimes that's a good thing, but sometimes that's a negative.
I mean, as we are kind of revolving around science and maybe some labs, I mean, does progress always have to be a product of a toxic relationship in the lab, or I don't know. I'm just riffing off now, but this is interesting that sometimes you just have to go into conflict or have a beef with someone to come up with something new. But like, why is that? Could you develop something just because it's nice, or is it not fast enough? Is it just not cutting edge enough? If it's not born out of fire.
Hi, I just heard that you were talking about, I kind of jumped in a little bit, so maybe I'm taking this off topic, but we were just talking about, were you talking about team working and how well you work together as a team? Maybe we were talking about that. I have a theory that people who grew up playing team sports are much better collaborators, and they know how to work together as a team. I don't know if that's a controversial thing that people feel.
So I've got some new people at the table, so we'll do another round of introductions. Is that good? So joining us, we have...
Hi, I'm Manusa.
And Manusa, what do you do? How are you involved in genomics and AI?
Well, I'm doing my PhD in reproductive genetics, but I'm also a senior scientist at Life Research Oxford, so we look more on epigenetics and male infertility.
Fantastic. And if we finish off the round of introductions?
Hey, I'm Margot. I'm an artist and a resident Scooby-Doo.
I'm Mikey. I'm just pale, male and stale.
Hi, I'm Lucy, and I'm here to have fun.
And my name's Brad, and 5 minutes ago I was honestly sitting on this side of the table and got roped in only because I know his brother somehow.
Talking about my brother, who's like the single sample of what I know about how scientists think and work. He had a beef. I'm not going to say who with, but it's probably there documented in all the letters to the papers. He had a beef about, I can't even remember, it's something to do with calorie restriction and aging. It wasn't with Brad, no, but it was this one scientist who was very big in the field, and it was like, no, this guy is wrong, I'm right, he's wrong, I'm right. And there was this kind of, that's how the sort of science, and he was desperate to prove that he was right and the other guy was wrong. And he was also a little bit jealous that this guy had his own lab, da-da-da-da-da. At the time he didn't have his own lab, now he's got his own lab, so maybe that's better. But that's one way of, I guess, of doing science, of how a science institution works. Come join.
I think sometimes science is driven by scarcity and a lack of resource, so we get to natural conflicts, don't we? We're talking about how we do science, about conflicts, around the beef, around sometimes different groups having different group dynamics. We've got 2 new people joining us, so we'll do 2 quick introductions. Hi, why don't you say who you are and where you've come from today?
Hi, my name is Wathaya. I'm a bioinformatics apprentice at AstraZeneca.
Fantastic, and also here?
Sorry, what's the question?
Why don't you introduce yourself?
Yeah, sure. So my name is Jay, and I'm currently a postdoc at the University of Cambridge. So I work on ancient genomics. So yeah, we study the genetic material of very ancient stuff, DNA from ancient soil, and to figure out who they were.
So cool. That is so cool. So we were talking a bit about conflict, around conflict driving science, about it, sometimes relationships, sometimes a bit of beef. What do we think about that? Have you ever seen any of this in your lives? Is it important for science? Is it good or is it bad? Is there more nuance in that maybe?
If I may? So my field, it's been driven by, let's say, in a good way, it's self-motivation. So this means we have pretty big names in our field, and they don't like each other. And then I guess, but luckily they don't conflict necessarily in terms of science. So I think in terms of science they actually have a consensus, and so we kind of agree on what each other is doing. We just don't like the fact that they're doing it.
I didn't even think about that aspect, the idea that maybe just because you don't personally get along with them, you can still agree. I just naturally went straight to conflicts and these passionate disagreement or arguments between people. I've run out of places to go. I'm running out of riff. Thank God there's a hand behind me. Pass Mark.
I mean, my question is this: is it that because are the two people in your field that are the big names that don't like each other? Are they male? Are they men? Are they women? They're men, yeah. Because I'm just wondering if this puts off. I would just like to ask maybe the females around the table that if this kind of, is it a male thing to have these kind of big conflicts, and maybe that's putting off women from actually getting to run their, because they don't want to do this conflict. I don't know. That's a question.
I'll open it up to our audience. What do we think? As a pale male stale scientist.
I think academia breeds quite toxic culture and allows anyone at the top to be quite toxic. So I've worked in cross-academic teams. Notably, I can think of 2 female bullies. So I think there's also male bullies. I think the culture in total allows for people to be not necessarily good managers, but if their name gets on that paper and because the person below them had to work really hard, that allows them to take advantage of them. But also, I think it is a very difficult culture for women to function in, just in terms of any sector. So sometimes you have to be almost firmer and harder than your male counterpart to be taken seriously. So there are reasons why maybe there are slightly firmer women at the top than otherwise. So it's a lot of factors, I think.
Anyone else want to play on that one? Any other thoughts and opinions?
Just to add to that, so I think me personally, I always find it hurts more when it's a female bully. I always feel like, women should stick together. Like there's so many things around women in STEM and, women empowerment. So I feel like it's always a little bit more painful when it's other women, attacking, other women in the industry or in academia or any other field.
I guess also I just like to be aware of, if we're just talking about women, we've also got like intersectionality that we have to think about. So it's maybe difficult as it is for white women. I think it's much more difficult for women from other heritages. Heritage? Is that the plural? Heritage? Heritages. And women of colour, is that fight harder? Does that make them have a harder exterior? Or what do you think?
What do people think of that question? That's quite a deep one.
I mean, I think that regardless of what kind of field you go into, I think you need the kind of set of social skills, or like hard skin, or the thick skin rather, to be able to face those conflicts and situations in life, which are just part of human experience. And sometimes, it's a bit harder to deal with that, especially when you are, when you know that you know stuff, and yet you still have to prove yourself to be more entertaining than the guy behind me. I don't know. That's a very good point. I don't know who this is at all. Are they even human? No, but what I wanted to say is, like, being an expert in your field, that's just half of the battle, it seems. It's really not what you know. It's like how you deal with people undermining you, or being bullies, or, needing to become almost a celebrity in your field to be heard and stuff like that. And yeah, it's like two jobs we're doing all the time.
Yeah, I do feel like sometimes there are celebrity scientists that some of us know that are big names that rise to the top very, very quickly. It's interesting to think about, isn't it?
I mean, you got Darth Vader there. I mean, Darth Vader's not necessarily got a big friends list, but he did get the Death Star built. So, you can see both sides of it. I think we just assume that Darth Vader is like pale, male and stale, but because he's wearing that costume, we don't even know anything about Darth. But there's a lot of assumptions, which I think are fair assumptions to make.
And just back on what you were saying, actually, I think there is research that women are possibly more sexist than men, which I think is just an interesting thing for us to think about in our unconscious bias in the teams that we're working in. And I guess the question that I have is that sometimes you find that when we're in smaller groups, I would like to hope that groups can collaborate together and see their
isolation as a commonality, but there's often cases where the groups turn on each other, which feels like a huge shame. How do we work around that? Do we see that a lot in academia? I see it a lot in society, and that's where it hurts, but do we see that in our workplace?
So talking about conflict driving progress, but sometimes conflict destroying progress as well, or slowing groups up. I was thinking about it as you're all talking about it in terms of like a traditional Darwinistic approach of like one succeeds so one fails in conflicts versus the idea of maybe collaboratively succeeding.
I've got a question to people, like what drives science? Is it kind of wanting to do good for humanity, or is it business? Because my theory is that maybe it's where the money is, maybe the business is driving science, and that means all of the like horrible traits like competitiveness or the sexism or whatever. I mean, I don't know. But that kind of outcomes driven and is it really good? There's no room for kind of being wishy-washy or collaborative because that is just not making money fast enough. So what do people think drives science?
I'm going to do something about this cable at some point. Did you want to weigh into that?
I didn't have anything massive to say, just that I think that in every industry, money is a good motivator or powerful motivator. And I think in science, it's somewhat unique in that a lot of people are driven by the desire to do good, hence why you have loads of like people working in research despite not being paid necessarily as much as in pharmaceuticals. But I would say that for the most part, yeah, money is a powerful motivator, I guess.
Keep going around the circle. Final thoughts.
I think it's also just important to note that without money we can't really do anything. So at some level, yes, of course, how much the company is making so that it can be put back into research is also important, but as long as it doesn't destroy relationships within the workforce or diminish people's values, then I guess that's fine.
Fair enough. Final thoughts.
On the question we talked before?
What do you think you've heard today so far?
Well, actually, I'm here to figure out why I'm doing science, So sometimes, well, I guess you do it for much longer, but, well, I do need to have some new views of to see what are the new, drivers.
Yeah, I don't know. I'll be interested to find out what are people's favorite stations around the festival, just because Custom House, I don't know, that's a station, yeah. No, but I mean different booths. No, because people are interested in different things. So it's about getting the better ideas, the better machines, the better investment in what you do. Because I think I agree with you. Sometimes if there's no money going into your line of work, then you can't do what you want to do. So yeah.
Bringing the dad jokes.
Well, yeah, I mean, it's nice to have you in the middle, Brad. So sorry it had to end. I'm just going to hit you with some positive sounds, but I'm going to fix this situation. We probably could get another XLR cable from somewhere, but it's been a very illuminating little round of discussion. I think sometimes we talk a lot about the science, but we also need to talk about how the science is done, what the culture around that science is, because it does actually affect the results of the science. But also what's considered important is what the people that lead the labs consider important. So the culture of the science does actually affect the results of the science.
I think it's a really, really key point that I try and remember as a senior scientist. I don't think you got a chance, so final words.
We need to find commonalities in our...
To the side.
We need to find commonalities in our differences to be able to collaborate better.
Because I felt Lucy's question of the team sports was never answered. But my favorite team sports was dodgeball. What does that tell you about my collaborative skills? I don't know.
So we will be back. We're just going to fix the Talkaoke table, a little technical hitch, but we will be back shortly. So stand by for more Talkaoke. Let's give Brad a huge round of applause. He's a natural. This is his first time, but I don't think it's going to be your last, and we will be back shortly.
Yeah, my name is Margot. Who do we have here? What's your name?
Sorry,
What's your name?
Jan.
Jan, welcome. And we've got?
Mikey.
Amazing. And as I said, I'm Margot. Maybe this person over there, she's looking curiously, but we don't know. Grab a seat for 2 seconds. Give us 2 seconds of your time. You'll make us look busy, and then other people will come. That's usually how it works, Jan. So, you know, it's nothing too deep, I hope. But anyway, so as I was saying, this is Talkaoke. It's a pop-up talk show. The way it works is people on the outside decide on the subject of the conversation, as the people on the outside right now are you, Jan, and you, Mikey, and maybe I'll put this headset on. We don't have any subjects. Do you have a subject for us? What brings you to Genomics Festival? What's it all about? What's the best thing or the worst thing that you've heard so far today? Jan, what brings you here? And maybe this person as well. I know she's always busy manning the table over there, but stuffing the table. Come and join us. What's the most interesting thing you've heard today?
I haven't. I've just been working, so.
I mean, is it all about work in the world of genomics? Is there any room and time for play?
No room for play. No, all just working.
Okay, it's all about work. There's no room for play. Do you guys agree over there? You can't hear you. Well, come and join us, because we do need more people around the table. Yeah, well, the point is it all about work and nothing about the play when it comes to genomics? Come and join us as well. Jan, are you a hard-working person?
Well, sometimes I guess. Yeah.
Sometimes?
Yeah.
Okay, so it really depends. Welcome to Talkaoke. I was concerned about the sound spill over to your station, but you can't hear us, can you?
We can't hear you, but it kind of comes blurred, and it's just sort of teeny, and yeah.
So just background noise. That's okay. Well, when you're in an epicenter like you are right now, maybe you'll actually be able to join the conversation. But as we are having hundreds of new people joining the table, see, Jan, I told you, you sit down and everybody else is going to join. That's how it works. This man knows. Exactly. So, some interesting interference is happening here. That's not my phone. That's not my phone. Who's got a phone with them? Maybe it's this? Anyway, I'm just going to use this mic, but first of all, I'm just going to do a round of introductions. So my name is Margot, this is Talkaoke, the pop-up talk show. What is your name?
Ursula.
Ursula. Ursula, welcome.
Mikey.
Lucy.
Alan.
Alan.
Jan.
Jan. Okay, welcome everybody to Festival of Genomics. As I mentioned, it's Talkaoke. I'm going to reiterate that it's really down to you guys to decide on the subject that we are discussing. It can be about genomics. It will be appropriate as we are at the Festival of Genomics, but it doesn't have to be. And besides, the subject can change, and it's completely up to you how you do it, what you want to say. Anybody's got anything to say straight off the bat? I can see your hand, Mikey, but yeah.
I wanted to talk about underwater hockey, and if anyone wants to play, yes, I run the Lewisham Underwater Hockey Club, which meets at Forest Hill in South London. If anyone wants to come along, it's free to them.
Do you have to be from Lewisham to come for free?
No, you can go online, Google Lewisham Underwater Hockey, and sign up to have a go for free. And if you survive, it's a great thing.
All right, so Alan has dropped a subject. I don't know quite how it relates to genomics. Maybe it doesn't, but it does link to underwater sports. Anybody here from South London? Give me a shout. Yes. Okay. Whereabouts in South London are you from?
I'm in Peckham.
Peckham. Beautiful. I know one other person in this situation from Peckham. Great. Have you ever played underwater hockey?
No, I have not.
What is stopping you, do you think?
Don't have a pool at home, I guess.
Okay, is having a pool at home essential for playing underwater hockey? Where are all the batteries? They will be in the silver box. In my bag. in my yellow bag in one of the small pockets.
What's the difference between on-land hockey and underwater hockey? On land.
Online. So what are the differences? Does it actually relate to genomics? Somebody asked earlier, are you more of a collaborative scientist if you play team sports?
I think so. My treasurer for the club, it's a club, so it's non-profit making, and the treasurer's a nuclear physicist, and we got some other physicists, and we got different kinds of people.
Okay, so physicist is in charge of your club. I mean, is it useful to have a scientist on your sports team? I mean, are there any scientists in what kind of sports do you like or follow?
Well, I'm not really a sports person, sorry.
Okay, what kind of stuff do you enjoy doing just for fun?
I mean, the closest to this subject I can think of is that I cycle to work and keep fit that way, but that's maybe not very remarkable.
Okay, well, cycling to work, I'd say that's pretty good. I cycle, we've got cycle sound effects, so I think you're more than qualified. Does it help to be, are you a scientist?
Yes.
Does it help to be a scientist when it comes to cycling? Are there any overlapping skills?
I mean, I get to think about science while I'm cycling.
Okay, so the best of both worlds. You are physically active and you are thinking, pondering different ideas. Ursula, what do you do down in Peckham? That's what I want to know. Are there any, when do you think about science? When is the best time for you to think about science?
Not on the road.
Why?
Too much traffic.
So what is the kind of most science thinking conducive environment for you?
No, when I'm running around trying to sort of do the other things that prevent me from doing science, frankly, it's like, oh, I should have done this, oh, I should have done that.
Okay, so in a way, the more busy you are with mundane stuff, the better you are at thinking about science.
Yeah, I guess so, yeah. Or in the shower, you're like, oh, should have looked at that. There you go.
Yeah, okay. So all these ideas they come up with in the shower or on the bike, do they actually make it beyond the shower cabin? What's it all about?
I find that when I'm in the shower, I don't know what it is, if it's to do with the heat, but I suddenly enter like a flow state of thinking. So I'll like stand in the shower for like 15 to 20 minutes because I just somehow think it's like feel the same as when I'm exercising. I'll just suddenly like drift into thinking all of these different ideas. Linking it to genomics, maybe people can think of ideation in the shower. But I think that's right. I would like to know what the physiological process is behind that, of why you enter. Is it the heat?
It's the flow state. Because you're in a flow, that's all.
Yeah, do you agree with this, Ursula? Like, who here has ever ideated in the shower? Obviously.
No, like actually, while people go to the stand I'm supposed to be standing in. I think there's a paper that showed some eureka moments in science I've actually come across from people being so relaxed and then in the shower, right? Yeah, I've seen that paper.
Okay, I'm gonna spin around because it doesn't work like this.
The eureka came from being in the bath. I mean, eureka, the actual original eureka story was not I don't think there was a shower in the Archimedes time. If there was, maybe it would have been a shower, but it was a bath. And I do most of my good thinking in the bath.
Okay, so it was about bath, but also it was about shower of ideas, or maybe having one strong idea. I mean, where do you come up with your ideas? Alan, I'm going to come to you and come and join us. This is just a harmless talk show, How bad can it be? We're just chatting about coming up with ideas in the shower. And you kicked us off with something that's got not that much to do with genomics, apart from the fact that people are involved in your underwater hockey, because you have to be a human to play, I suppose.
They're all wonderful people, that's it. It catches. Anyone who plays hockey has to be wonderful.
Okay, it's a very simple formula there. My name is Margot, what is your name?
Makungu.
Makungo, welcome. We've got Alan, we've got Jan, we've got Ursula, we've got Mikey and Lucy, who's getting the mic right now.
There was a researcher, I think he looked at, because lucid sleep, like as you're drifting into sleep, you can have your most ideation then. And I think what he started to do was I think he would fall asleep by the fire with 2 metal balls in his hands and then a metal plate below, and then as he would drift off and be having his amazing ideas, the balls would fall to the floor and wake him up so that he could write them down. That was his scientist, if I think. Do you know who it is?
Well, Salvador Dali used to do that, who was an artist, but other people he may have got the technique from some other scientist.
Okay, so this is where we are at. This is a talk show which is fueled by you and your ideas and your subjects. Right now we're talking about, just what you heard. Plus also, in the world of science, as your colleague was saying, is it all about work? Do you have time to play? Also, what are the best circumstances for you to think about science, think of new things? For Ursula, is the more she's doing stuff unrelated to science, running around, being busy, or in the shower, that's when the good ideas come to her. That's what happens. You run an underwater hockey club, which anyone can join. The physicist was the club master. Well,
that's right. Yes, we're all genetically linked playing underwater hockey. We got fins as feet.
Okay. So yeah, you have to be genetically linked to these people to play, but that's not that difficult. And we've got a new person. Welcome.
Hi, I'm Eva. I was going to say, as someone with very flat feet, I am definitely genetically predisposed to do swimming.
Swimming, okay. I mean, when you swim, do you think about scientific ideas? Ursula, give us a final thought before you go. Do you have a final thought?
When?
Final thought about anything. Message to the world.
Enjoy genomics. Yes.
Thank you. We will try our best, that's for sure. Yes, so what do you think about when you swim?
Honestly, it's about the politics of the swim pool, because I want to be faster than the person behind me, but not held back by the person in front of me. I'm a competitive crap swimmer, if that makes sense. So I just thinking about, that person never lets me overtake them, and then, oh gosh, I'm going too slow for that person. So it's a social interaction. In terms of being in the zone and having good ideas, I do agree, going back to the bigger issue and not my micro pool aggressions. The bigger issue is, I think there's a lot to be said for getting ideas about something when you're not looking at it. When you look at something directly, sometimes you can't see it. And I think it's, there's an analogy, I think, when I came here about art, and I think there's something about that, about being in an environment and just taking a break from something in order to understand the thing better.
Several things. Jan, you're going, so do give us a final thought now, and then I'll do a quick summary.
Okay, well, what can I say? I heard a bunch of stuff about artificial intelligence today, and I'm going to say that particularly large language models are very good at recycling what they've been fed, but they're not really intelligent. Maybe because they don't swim and they don't cycle. If we can get them to do that, maybe that's an idea.
Okay, so maybe could we get AI to be less direct? Maybe we'll come up with better ideas than humans. Thank you very much. Grab one of our cards if you have it. Good.
AI gives us time to think about other things that matter. For instance, if I have to read 2 articles at the same time, instead of taking me 10, maybe 4 hours, I'll read that in 20 minutes, 30 minutes. That leaves me with much time to concentrate on other critical things.
Okay, so time seems to be like a currency, or if we've got time, then you can allow yourself to come up with ideas. But is this a common thing of how scientists do things? Are you a scientist?
An emerging one, yes.
An emerging
Yes.
Okay, what are you emerging from?
Originally from Africa, so my research is on HIV and type 2 diabetes. So where I come from, there is a high prevalence of type 2 diabetes in people living with HIV. So that is what my team and I are trying to research on. How can we reduce this comorbidity that is burdening our community?
Okay, so it's a very specific field of research.
Are they linked? Type 2 diabetes and HIV. Do you have a mechanism?
We hope to find a link. So the basis is HIV by itself is a chronic infection, yeah? So that chronic inflammatory reaction in itself predisposes the beta cells to being depleted. So in essence, that reduces your insulin levels. But also remember that, excuse me, also remember that these individuals are on antiretroviral drugs. Okay, so the combination of antiretroviral drugs, the HIV itself, as well as them living longer, this predisposes them now to, coupled with sedentary lifestyles and the other lifestyles that they are adopting, that is what is predisposing them to type 2 diabetes. Okay?
So there is a link between maybe...
I must mention that when you look at the prevalence in terms of the general population and the people living with HIV, those living with HIV have a higher prevalence, which is 2% to about 27% that has been reported in Cameroon. From my country, it was 3.5%. In Cameroon, about 25 or 27%.
Okay, so big differences. Yes, Lucy and Alan, also, if you have anything to chime in on, is there a link? I mean, because you're talking about people taking maybe medication for HIV and that kind of impacts their lifestyle and subsequently how they're prone to diabetes type 2.
On a personal note, you're making a difference, and that's it. So when you go to sleep at night, you think, hey, I'm trying to help people and make a difference. And you can puff up your shoulders and say, I'm not just a waste of space, I'm doing something.
Okay, so it's about doing something, have a purpose, also have a good night's sleep, very important for creative thinking, for being in the flow.
What do you think the difference is between the countries? Why is there such a big difference in percentage incidence?
I would attribute the percentages, first of all, by the prevalence itself. I do not think, when you consider the prevalence, you'd find that sub-Saharan Africa has almost 26.6 million or 27 million of the overall world HIV population. I don't think the UK has such a number. And when you talk of a country like Zambia, you'd find that about 1.2 to about 1.3 people are currently living with HIV. I'm sure that would be maybe the number of the overall infected individuals in the UK or some other Asian country. So that burden in itself, and also the genetic diversity, that may also predispose maybe our population to HIV than here. But the other most important rider is the divide in terms of equity, health equity, access to health care, and also the overall health literacy. Because when you look at the dissemination of information in terms of prevention, in areas where there is no internet, where there is no TV, where there is no radio station, compared to a country like this one, that already it will take time for our people to get the information. Poverty, maybe I shouldn't even talk about that.
Okay, so there's a lot of... I just meant in terms of the diabetes link. Like, I totally get the distribution of HIV across the world is a complex topic, but you said that from the country you're in, it's 3%. What country is that? Zambia. And then in Cameroon, it's 25%. So are those reasons that you listed relate to the diabetes link, or do you think there's a reason why certain countries have such a stronger prevalence of diabetes and HIV versus other countries?
The specific answer to that, I wouldn't know because I've not looked at that. However, what I would say is our question that we were trying to answer is purely on individuals who are infected with HIV. Why are they susceptible to type 2 diabetes? Among other non-communicable diseases, okay, why are they susceptible to type 2 diabetes mellitus? There is type 2 diabetes mellitus in the population other than the individuals who are HIV infected. That is not our concern at the moment. Our concern is the HIV population because that is higher than the general population. And if we let that unattended to, then the 26 6 or 27 million that I talked about, if we go with even an average of 15%, then chances are that in 5-10 years, you might have out of the 27 million people, about 10 million people infected. 10 million people with developing type 2 diabetes mellitus.
So you're suggesting that type 2 diabetes is an autoimmune system problem that we haven't sort of labelled it as such up to now?
Not quite. The autoimmune is separate, which is type 1. Type 2 is more of a lifestyle disease, okay? So this is where you have the insulin not working or insufficient insulin being secreted. So what has been shown in HIV is that the drug itself that individuals are taking and the virus itself, coupled with the chronic inflammation itself, these have a direct effect on the islets, and that affects them producing insulin, and this is what leads to type 2 diabetes. Now we want to go into the tissues to look at the microenvironment and look at the distribution of these cells, the chemical gradients, the virus itself, as well as the cell elements, and then hopefully we'll come up with an answer.
Okay, well, thank you so much for giving us the perspective from Africa, from Zambia, and other things. And yes, where do we want to take this conversation? Do you want to delve more into the subject of distribution of healthcare knowledge about different diseases and possibilities out there? You said about poverty as well. It's like, oh, let's not go there. But can you talk about science progress without addressing the equality? That's just another question. We can go back into, you know, the sports, which are good for scientific progress, or none of the above. Mike?
No, I just wanted to pick up on that. That's the question of, yeah, I mean, it's always the rich people's diseases that get, you know, we had a guy earlier on that was concerned with aging. And aging is a good thing to research if you're fit and healthy and you've got to an old age, but this is more like a rich person's type of research, and there's probably way more research into aging than HIV, especially in sub-Saharan Africa. That I think the most HIV research has been done on Western people. So yeah, I think there is a massive inequality, and I think that's something that's come up quite a lot today, how our targets of research kind of reflect the inequality in the world.
Very good point, Mikey. You have to go. You were going to go. Give us a final thought. It could be a question, a provocation for the next round of conversations, and maybe somebody who is actually knowledgeable about science can jump in the middle. But give us a final thought about anything.
Africa is ready. Africa does not lack talent. Africa lacks access. If we partner and collaborate with any researchers from any part of the country, any part of the world, Africa will have their health issues sorted. Thank you.
Thank you very much, and thank you for sticking around the Talkaoke table. We are here all day today and all day tomorrow, so do come back, tell us how the festival is going. But thank you for letting us in on your research. Alan, you're going as well? Yes. What are you off to do, and what are your final thoughts?
Final Trump has some, when he talks about everything is down to money, I mean, money is important with Africa, especially because the investment's just not there. It's very hard to invest in Africa and get it to the right place. So, anyway.
I mean, you mentioned Trump. I mean, is geopolitics in any way related to where the money gets invested?
It's always related. I mean, geopolitics is my forte. I'm a political economist, not a scientist.
So you're here on a covert mission, a bit like me. But why are you here?
representing the patient. So I'm since I retired, I'm a patient, called PPI, patient and public involvement person, and that means we give back. I've had a cancer since 2007. 18 years I've had this cancer, and I'm only alive because research was done on it. So I support researchers and I give lectures to researchers on how to involve patients in their research, which is patient and public involvement, and also represent the patient. You know, when you give your data to a hospital, you go in, you gladly tell them your age, your date of birth, and what's wrong with you, and all that data is what I am a gatekeeper for that on lots of committees, because they can't. It belongs to the hospital, but it also belongs to the patient. So they need representatives, so as patient and public people, a patient advocate who represents them and looking out for their point of view. And it means that I don't think I'm a waste of space as I've got to 80. I'm still out there trying to represent all the dyslexic idiots that are shy, and I'm not shy. See, I'm a dyslexic idiot, and but I think it's a responsibility. So that's why I'm here, to check on the scientists, make sure they're doing it right.
Yeah, exactly. Just like I think the job that you're doing is absolutely amazing, and you're 80 as well, which is I mean, it's amazing. So congratulations on that. But also, we were having a conversation earlier about science communication, that kind of interface between scientists, people who are really in the know, the experts, and the rest of the population. You're representing the patients. I mean, are there any kind of obvious mistakes the scientists make when speaking to public, speaking to patients? What kind of stuff have you advised them on to do or not to do?
I spent 24 months, I was hired by an American company to put empathy into their algorithm. And how do you do that? I thought, as a laugh, I Googled it, and there's no one tells you how to do it. But basically, you sit in the Teams meeting, because the time difference with the US and different place, and you all the time thinking, how is that going to affect the patient? And you bring it up and you say, how can this top surgeon sitting here, how can he interrogate the AI and to see how it came to its conclusion? Has he got that facility? Because we were matching experimental cancer medicines to patients, and the DNA of the cancers and the DNA of the patients as well. And we were looking at dead data, you know, patients who had died, so or not live cases, and we knew the outcomes, and then we compared it to the company that wanted a foothold in NHS, you know, so they were funding this thing, so that I was getting paid for that one.
Well, that's always good. I mean, you know, it's always good to get paid for your knowledge. And also, Alan here is an expert on teaching empathy. Do you have empathy?
I should for this book, yeah.
Do you know this man?
I do.
Do you know him from Lewisham Underwater Hockey Club?
Oh yes,
yeah.
We were in a meeting yesterday of genomics and AI.
Grab a seat for 2 seconds, because that hardly ever happens. So I'm Margot, this is Alan, whom you know. This is Lucy, this is Mike, this is Talkaoke. What's your name?
Alex. And what is happening here?
Very, very good question. So this is a talk show where people on the outside, and these people over there, you can come and join us if you want to. We're just having a chat, but the conversation topics change all the time because different people sit down, like you, Alex. You may want to talk about something completely different, but so far we have been, yeah.
So, and where does it go to afterwards? Or just in the now? This is it.
It's both. Right now is the most important time for this talk show, so you are in the right place at the right time. This is our card. It will at some point go on YouTube and maybe Spotify if we say enough clever.
You can persuade me to do anything. You're very good at this.
There you go. What would you like me to persuade you to do?
What's the first question you have?
My question is, I'm going to bounce it back at you, but I don't actually decide on the subject. What should we be talking about? Yeah, Mikey?
Oh, no, go.
Yes, Alex?
It is interesting that in our modern life we only see each other virtually. And this festival has helped us to physically say hi. So that's really interesting. So we've known each other.
So it's a meeting.
We're both on a panel called GAIN, Genomics AI Networks, and it's got some funding, and we look into how AI is going to affect everybody, and we try to head off collisions between the patients and the AI, and we try to, so that we've got answers to them when they arrive. Is that right?
Okay.
That's a lovely summary.
Okay.
Of what the conversations are about, but it's led by clinicians, and there's a group of us patients, as public contributors, and they want to pass their research by us, but the bigger questions on the responsibility of the data and responsibility of clinicians.
Okay, well, listen, just because we've got two other people that have been neglecting on this side, because it's a round table, it's
I was curious about what the coloured lights were about.
Maybe you can demonstrate, Mikey. What are these things? But
well, if someone says, like for example, Alan was talking about underwater hockey, and I've got my splash sound. So that's basically it. It's a bit quiet. It's a bit quiet. 80 years young, and that's that button. Or have we got a magic wand to cure all the ills of society? There we go, that's the sort of thing that I'm doing here. Drop the mic. That kind of
drop the mic. But so yes, Alan. So this is just an enhancement mechanism to make the conversation less dry, less boring. Maybe you need one of these when you are talking to scientists. How are they dry people?
Always patients who are at the sharp end of everything, and are what the surgeons and the scientists are dealing with. Always when they step in to help patients, their research becomes better. It's enhanced, and that's it. That's my sound.
So now you know what these sound effects are for. But meanwhile, we've got a new person joining us. So my name is Margot, we've got Mikey, we've got Lucy, we've got Alan, we've got Alex, we've got the sound effects pad. Give us a shout out to the sound effects pad. What's your name?
Joaquin.
Welcome. This is Talkaoke. It's a pop-up talk show. We are jumping from one subject to the next, but it's really up to you guys to decide on a subject. We're talking about patient experience and collaboration between patients and scientists. Does that make better outcomes for patients and for scientists? You are teaching empathy to scientists. That's one of the things, and loads of other things.
I mean, I was at a festival, Genomics 2 festivals back, and there was this guy that's saying, yeah, we've got this incredible model of a tumour cell where we can do the genome of every single cell within the tumour and visualise it in this incredible software. And then somebody else said, how does that help a cancer patient? And they're like, oh, no. It's not actually, that's not what it's about, that. It's not about that. But, so, I think sometimes there is a bit of a gap between all this highfalutin research and we even heard it earlier on here today. What are the clinical benefits? And sometimes there is a bit of a gap. I mean, it doesn't always stay as a gap.
Okay, so there are gaps. I mean, in your line of work, I have no idea what you do. It could be absolutely anyone. But do you interact with patients? Are you involved in research?
I'm working directly with doctors in hospitals, so we sell genetic diagnosis tests for different rare diseases or genetic diseases. So, yeah.
Okay, I mean, how is that going? How is working with doctors going? Because you work with scientists. Do you work with doctors as well in your network as well?
I work in help doctors in primary care.
Primary care, okay.
Yeah.
Okay. I mean, how is that communication going? I mean, is it all kind of plain sailing, or what would you have to do? What's the most difficult thing about your job?
Well, it depends definitely, because definitely depends on the level of knowledge and genetics of each doctor, because sometimes you deal with doctors that they have no idea of genetics, and then you have to support them in all that aspect. And on the other side, it's doctors that know a lot, and then it allows you to have like a better conversation and this thing. So it depends. Like you have like a big range of possibilities there.
So this is, it is interesting. Come and join us if you. Do you talk about science? Do you ever talk about science? No, same here. No, but this is really interesting because we had a conversation loosely around the theme of science communication. We were kind of asking the question: at what point are you there to inform and kind of, I don't know, teach people some basic knowledge, and at what point do you need to just engage them in a dialogue? Do you have to educate as well as communicate? Yes.
Sorry, I'm going off piece a little bit because I've got a thought in my mind. But there's a theme about trust, and certainly at the start of the festival it was brought out. One of the pillars is for the patients and the public to trust what's happening. But also I think it applies to clinicians. Do GPs trust what's happening? So there's a communication piece to happen about trust, because a good GP would say, I look at my patients, I use my senses, I know what they're like. Do I need this level? That's a question of trust.
I think that's a very interesting question, and reversing almost or showing a different direction of this trust. It's not just patients trusting the scientists or doctors, it's also doctors. Do they actually trust the knowledge and science they have to have?
I have had a personal experience at a doctor's where they just, I don't know if this is the old-fashioned way of doctors treating patients, but they really didn't explain what was happening, and I had to go for further tests, and kind of something was happening that we weren't sure about, and I was just like, I don't understand. I lost my sense of smell, and so it was an ENT, and I was like, why is it happening? He was like, it sounds like it's COVID. And I was like, it wasn't COVID, and it isn't. I know it's not COVID. And they were like, well, and I was like, why might it be happening? And he was like, well, and I was like, I went on steroids and it got better. Like, that's not COVID, that's not nerve damage. He was like, yeah, we just don't know. But yeah, it is. I don't know. He was just quite firm about not really taking my worries and concerns seriously, and also I'm quite engaged in the science sector and medical sector. Like I can't necessarily articulate what I think the problem is, but just a sense of him not really caring about me and what I thought and what I know. And so I think there's a move. I know there are GPs, I've had the other end of the spectrum where a GP has been like, no, I think I had a bee sting or something, and I was like, they were like, what would you like me to do about it? And I was like, help me.
Okay, so you're talking about your experience as a patient. Also, how hard is it to be a GP these days?
No, to be a GP these days, all you need to do is have access to Google. You just Google, but you need to know what you're Googling, and that's where just the common Googler will fall down. But I just wanted to say that trust is it's not a factual thing. Trust is a emotional. It's a feeling, so it's a very difficult one. And actually, I've lost trust in various. Well, I lost trust in my opticians when he misdiagnosed my problem, and that trust never could come back. But at the same time, I feel like the trust that was built was more about a relationship than him knowing a certain thing, or there being a certain edifice of knowledge.
Okay, so trust is about the vibes, it's not about the knowledge. Do you agree?
I think yes, and it also has to do to honesty. If the doctor can recognize that, okay, I don't know this, but doesn't work. Don't worry, we'll check. I will research on this, and this builds up on the trust. So I think it's also together with the honesty of the doctor regarding XYZ topic.
Do you trust your GP?
I just moved to another country, so I'm building up that.
Okay, what are you going to be looking out for in your GP? Is it the way they talk? Is it the way they dress? Is it the hard knowledge? Is it, all that stuff? Thank you, Joaquin.
On the note of that, I was exactly going to say that. So I didn't used to trust my GP at all. I don't really trust GPs. They didn't catch my dad's cancer, and he got stage 4 cancer, and he probably had stage 4 cancer at that point, but it took a very long time for them to diagnose it. so I just don't believe that they have any knowledge. But my friend is now training to be a GP, and in her training to be a GP, they do a practice assessment where you give a friend like all these different case studies, and it's like, this is the information, do not reveal this information, and you have this whole thing, and then they have to like have a practice what's it called, consultation with you. I as the patient had, it's like you went on a hiking trip and you got bitten by a tick, but only reveal this when directly asked. And yeah, there was role play. Yeah. And it just made me realise that there's so much stuff that people don't realise might be and one of the ones was that someone had Lyme disease, but they forgot to mention that they went on a hiking trip, but they were feeling really tired. And I just suddenly realised that actually to be a GP, I used to have no respect for them, but it's actually in 10 minutes to get all of that information and ask the right questions is actually really difficult. So I do have slightly more respect for them now.
Okay, so being a GP, a little bit like being a Talkaoke host, you have to be able to ask the right question, and when you are diagnosing the Lyme disease, you have to tick some boxes to get closer to the answer. Anyway, I'm just doing it for gags and gags only.
Well, I would say being a GP is exactly the opposite kind of question that you ask as a Talkaoke host, because as a Talkaoke host you're asking a question which is opening up the conversation, whereas being a GP you're trying to narrow something down. So it's both about asking the right question, but in each case it's a very different type of question.
Okay, so I mean, there's several subjects on the table. There's the empathy towards your GP, who actually has to navigate lots of things, be able to ask you the right questions, close questions, not open questions. There's the trust, the knowledge.
I seriously think that GPs will be replaced by AI.
Okay.
Because when you go to the doctors in the future, let's just get a final thought from Alan before we go.
It's like a boat. What are you going to do now?
Trust. Do we trust Putin, or bringing it back to the important things, political economy, do we trust Trump? I mean, when he gives his word, he's going to do something.
Okay, so how important is geopolitics to our health? I mean, you are a political economist.
It's a background depression that's spread over the country, and people just feel that they're wasting their time because someone's going to push the button, and they're gearing up for Iran at the moment.
Okay, so are we living in a world of shifting priorities as well? If defense gets prioritized, what gets deprioritized? How does it link to genomics? Does it? I mean, I don't know. I'm just here to ask questions. Alan, have a fantastic rest of the day. We're here today and tomorrow, so pop in later.
I don't know, it was very uplifting sort of analysis about science and genomics. Suddenly we've got, we're descending into World War III, so I'm not sure really what to make of Alan. He seemed to be quite happy when he was saying that as well. It's like, oh, World War III's coming.
Okay, so can you be upbeat about the...
I saw something today, or maybe it was last night, about Putin's plastic surgery. If you look at pictures of before and after of Putin, he's had actually quite a lot of work done. It's like filler under his eyes, they had a facelift. Just thought it was very interesting of these large geopolitical leaders also having work done as well.
Okay, so here we are at Festival of Genomics. My name is Margot, this is Talkaoke, this is Mikey, Lucy, Joachim, whom I think you know. What's your name?
Jesse, from Brazil.
Jesse from Brazil?
Yeah.
Right now we're talking about plastic surgery. No, I won't, but we could. Is there a link between plastic surgery and football and genomics? Anyone who can come up with an answer will get a special prize. I don't know what that is. Mikey, 1 second. And then, go on.
Well, it's not Gary. It's just about narcissism, isn't it? It's like, and last year we had people studying the genomics of personality, and you can actually find narcissism within the genes or other personality disorders within where you can draw correlations at least. It's not the same thing, I should say. But political leaders tend to be very narcissistic, and that's why they go for the plastic surgery.
So many questions I want to ask. First, obviously, is what kind of plastic surgery would you like to have done? Have you had plastic surgery done? What would be the first thing that you would do?
Just a bit of baby Botox.
Baby Botox. We've got the baby, we don't have the Botox sound effect. But also, what about these kind of personality traits? Are there any particular personality traits which are useful, relevant for your line of work, or for being a political leader, or for being a scientist? I mean, is being a narcissist a good trait for a scientist? Are you a scientist, Yassin?
No.
Listen, be honest, we're all friends here.
Hard. I don't know.
What are you?
This I know. So I'm leading a software platform.
Okay.
Yes, at Centogene. Yeah. And so we are offering the possibility to change the future of genomics is reshaping with the possibility to decentralize the medical information. So this is a very important aspect for the future of genomics, decentralize it. The information, not just in specific centers in the world, but we can give the possibility to other capitals, especially when we are talking about countries, not rich countries, but the possibility to them to offer better solution locally for genomic access, etc. And this is why software can develop this type of thing, can release this type of thing. So this is my job.
Okay, so we moved from baby Botox to almost like major tummy tuck of the genomics chat. So you're going for decentralizing decentralizing genomics or the access to data, and it's particularly relevant in poorer countries. What's the situation in Brazil? Do you work in Brazil as well?
Yeah. In Brazil is the fourth largest market in genomics in the world. So, and of course, that is very important because the genomic market is changing, and this type of market is very. Every year we have change. So, for example, in the past, some years ago, we needed to send samples to other countries to analyze samples. However, today is another reality. Today we can do the things locally. So, with this type of thing, we can release to the patients more efficiency in terms of turnaround time, and of course in terms of data information as well.
Okay, so keeping it local is actually to the benefit of the patient as well. I mean, where do we want to take this conversation? I mean, decentralizing, and you run it's a platform, right? It's a software platform. We're talking about AI. We have been talking about AI before. Where do we want to go? Because this was very, it's very, very deep, very specific as well. And how has it been in terms of Festival of Genomics? Is there a lot of interest in your work? Is it more about let's centralize it because it's easier that way?
Yeah. This is the idea. The idea is connected the artificial intelligence with the databases, public databases existence around the world, and of course our biodata bank. That we have, for example, at Centogene. We have a specific biodata bank with more than 1 million samples, 1 million individuals from more than 120 countries. Yeah.
Okay,
And this type of diversity is that can bring us the possibility to offer a better solution in terms of diagnostics, because we have data from different regions of the world. And this aspect, it's very important.
I mean, diversity of the data has been something that we discussed as well, believe it or not, and it's about kind of diversifying, the biodata so the research can go further and help more people and different types of people. I mean, we can take it in any direction you guys want. I'm just interested in the last biodata sample you have given away, maybe?
Well, maybe we could connect it with the world leaders, you know. I mean, the world leaders probably have got a particular kind of biological data set. Is there anything about them that kind of sort of sets them apart? Probably, oh, look, quick selfie. Talk about narcissism, let's have a selfie. You know, are they just the same as all of us? I don't know. And yeah, maybe what about the Brazilian world leaders? Have they got a different
Do they trust
makeup?
the GPs?
Yeah.
I mean, you know, if we don't trust our doctors, like, you know, what about the world leaders? There's a lot at stake, right? If your doctor's a bit of a quack. Joaquim, any thoughts on this? Would you like to be a political leader of any particular country?
I mean, I'm from Mexico, but I'm not very interested in being like involved in politics. I mean, even though like everything we do at the end of the day is politics, but yeah, no, I try to avoid that.
Okay, so not too much politics, although everything is politics, maybe with a small p.
I read a very interesting, it was actually a video that I saw, not read it, but it's just better to say it that way. I saw a video that hosting dinners is the most political thing that you can do right now. So someone said that they're trying to host a dinner they've got 2 kids, 2 small children, but last year they tried to host a dinner every single Friday or every single Saturday, because right now our community is the strongest thing that we have, and it's just a very interesting reflection that can be something political that you can do. It's just chatting with people and connecting, which I thought was very interesting.
So dinner parties, have you ever been to a dinner party? Anyone? You have?
I have. I mean, I just want to say, I've just recently stopped drinking, and it changes the whole aspect of a dinner party because let's just get a final thought. Let's get a final thought from you first.
Listen, we don't have to be somewhere, but give us a final thought. Anything.
Anything regarding
Anything.
anything. So, I wish to you both a lot of success.
Same to you both.
Thanks for inviting me to join here. It was a big pleasure.
Listen, it's been a pleasure meeting you and finding about your work as well. Sounds like work worthwhile.
We need to talk about what they called La Gente Habla. We're starting off La Gente Habla. It's actually being based in Miami, but it's a Latin American version of the People Speak. So if you're interested, let us know.
That's true. Yes, that is true. Where do we want to take this conversation? We've got dinner parties, we've got being political, we've got not being political deliberately, we can change host, we can change host. You can be the host in the middle if you want, Joaquim. You can do it in Spanish, it doesn't matter, you know, it's okay, we can combine. No, that's going to be a very difficult job for you, unless we do La Gente Habla at some point, so, you know. Lucy,
final thoughts. I was just going to say that you said that having dinner parties is very different now. You don't drink, and I was going to say maybe it's your friends rather than the dinner party format.
Okay, do we need to change our friends?
I didn't get to finish my point. What I was going to say was that, first of all, you think, is it me? Am I boring now? Am I boring? Am I boring? But actually, obviously, I'm not boring, obviously. Yeah. But you just have to just be a little bit more silly, and it's like almost alcohol gives you an excuse to say stupid things, but you don't need that excuse. Anyone can say stupid things any of the time. So I would just encourage a bit more of that without drinking. Just say something stupid.
I mean, is it possible to be silly in your job, Joaquim, or do you always have to be like super serious?
I mean, it depends on how much trust have you built with the other people, you know, like, because it's like, I mean, like, if it's a new customer, someone new, like, of course you have to be some kind of serious, but still, like, you can put a little bit of your personality and, like, this also works out. And then when you already know somebody for a long time, then I guess it gives you space for making some jokes or being funny.
Okay, so maybe you have to create a professional, serious kind of veneer first, And then as you get to know people, maybe it's a bit easier to maybe crack a joke or discuss your plastic surgery that you'd like to have because you bonded.
It just links to that question about trust, doesn't it? Because we're talking about trust in doctors. You can't just come straight in with the gags. If you're like, you know, have I got cancer, have I not got cancer? I don't know, let's spin the wheel and find out. Obviously you can't do that. You've got to be serious to gain the trust, and then you can do the jokes.
Okay, so you're going to be serious. I mean, I always try to ask my GP how they're doing, which seems to be like a thing. I know I'm not supposed to have opinions, but I thought, you know, we're bonded now, so I feel I can tell you. No, and they always seem to be a bit thrown by it. I say, how was your day? And they're like, ugh, you know. But anyway, maybe they go, yeah. Anyway, I think I've just been timed out, so on that note, I will end my stint, but it's going to carry on, and the person over there can join us. Final thoughts, message?
Have fun, enjoy, be kind to others.
Okay, fantastic. We'll keep an eye on your station always.
Thank you.
Peace and love, folks. Peace and love.
Thank you, peace and love. What's the plastic surgery you would like to have?
It's not plastic surgery, but I was always considering like dyeing my hair a different colour. It's not really plastic surgery. Well, that was always the problem. I never knew what colour to do it.
Well, I would like to remind you, Mikey, that somebody has given you a pomade for your hair, which is supposed to make them dark, which you've never used. And on that note, we shall end this Talkaoke session, and maybe someone else can jump in. So, peace out.
My name's Mikey. What's your name?
Hi, I'm Margot.
What's your name?
My name's Natalie. Natalie.
Natalie, yes. That's what I thought you said, Natalie, yes. Okay, right, so... we will say there's no contractual obligation here. You can stay as little or as long as you want to. It's kind of up to you. And you don't... We can talk about anything. It doesn't even have to be science-based. Earlier on we were talking about underwater hockey, weren't we? Not that I'm really sure what it is. I'm getting some interference here. Anyway, I think it might be from. I might change channels. Anyway, we'll do that later. Anyone got any? You're going to join us? We need a subject. Yes. We'll give you a round of applause. Okay, so we have got Margot, we've got Natalie, I'm Mikey. What's your name?
Ikenna. Yeah. Samuel.
Samuel, yeah.
Jeffrey.
We've got Natalie, we've got Margot, I'm Mikey. You've joined us at a really good moment because we're just starting the Talkaoke. We don't actually have a subject. So has anyone got a subject they want to bring in? A good thing to talk about? And what would you like to talk, if you were going to be on a talk show, what would be your subject? In theory, yeah. Could be anything.
I would say precision medicine. Precision medicine, yeah.
Are you a precision medic?
Because I work in the NGS lab.
Yeah.
So, you know, when it comes to care, is moving towards tailoring whatever procedure based on the patient's response. So nothing works, even though so many things work in general, not all patients have the same outcome. And that is based on how they react to the treatment. And that goes deep to their genetic component. So I remember the first conference I attended, that was 2 years ago, and they shared a story where the patient wasn't responding to clopidogrel, and different tests were done, but nothing came back positive. Can I hold it so I don't stress you? Until they did like a whole genome sequencing, and they found that after comparing with the reference genome, that the protein responsible for clopidogrel binding is completely absent from the patient.
Right.
So for that same patient, clopidogrel wasn't an option.
What is the thing that it's binding to?
I don't really know the name of the protein. I don't know, it's a receptor, but I don't know the name. So it was completely absent because the gene is absent from on the patient's genome. So that gave a clue for another therapeutic to be used, and the patient responded to it. So could be the girl, a lot of people respond to it, but for that particular patient, something else had to be given with the intervention of genome sequencing. I think that's where the precision medicine.
I think that's the future of medicine.
It is, because a lot of people are actually moving towards it at the moment. Cancer and all of it. Then when it comes to, let's say, breast cancer, for instance, before you give certain therapy, you have to know what genes have been expressed. Because for the double strand, then we talk about if there's a repair mechanism for double strand, a particular drug would be given to the patient. But if there is no expression of the gene, you can give a certain drug, knowing fully well that it won't be repaired, and that has a negative impact on the cancer cells. So different patient, different outcomes, different therapy, and I think that's it.
So we're talking about precision medicine. We've heard certain stories in which it works. Precision medicine, how do we get more precise in our medicine? That's what we're talking about at the moment. Any thoughts? Are you a precise person? Let's ask the people around the table. Are you precise, Natalie?
No, I'm not.
You're imprecise?
I'm imprecise at the moment.
Okay, and what about you, Jeffrey?
I wouldn't say I am.
Yeah?
No,
You're not that precise. Are you precise?
I would say I support the idea as well.
Yeah, so you think it's a good idea. I mean, what's stopping us getting more precise in medicine, would you say?
I think we need more knowledge and more application. We need to get a lot of people to be aware of it, to even like the healthcare professionals to be aware of it. Then we'll be able to understand how to apply it. Even the patient needs to be involved as well. Because of course we need their consent. We need them to be we need them to know about this and how it affects their own outcomes as well. So it's a all hands on deck kind of approach that should work.
So everyone's got to get involved if we're going to make precision medicine a reality. We've got a new face. So Ikenna, Ikenna, Samuel, Jeffrey, Natalie, Margot. What's your name?
Lucy.
And what's your name?
I know.
So and I'm Mikey. At the moment we're talking about precision medicine, just because Ikenna brought it up. But is it just one of those things where occasionally, is it like in this case, it was a treatment of last resort, wasn't it? It was after everything else. They found some kind of protein deficiency which they could treat after exhausting all the other conventional medical techniques. But is that, will precision medicine be the kind of first resort rather than the last resort in the future? Any thoughts on that? Do you feel that your medicine could be more precise? Lucy?
Yeah.
Yeah?
Every drug has loads of side effects. I wish it was more precise.
Yeah? I mean, do you believe that we will get more precise in medicine?
It depends what precision in what sense, because also lots of you can be really precise, but things genetically are linked to other things. So if you change one thing, that will just biologically come with another thing. Like you make cows really big, but then they become really tired, or you know.
I didn't know that big I've got a sound effect for that. Hang on, got to. Oh yeah, there we go.
Like if you breed dogs, like you breed them really big, then their lifespan becomes shorter. So certain traits are linked to other things. So, we truly be precise.
So you think you're being precise in medicine, but at least when it comes to dogs and cows, you try and do something precisely, and then you have other effects. I know, have you got any views on this?
So I work in an
R&D
area of precision medicine. So we use lab-on-chip technologies to enable R&D in precision medicine. So one of the areas, I'm on this cool program where I get to travel all over the world to really understand how we can improve precision medicine as one of the areas. So what I'm looking at is in veterinary. So I know for animals, there's not much precision.
Any particular animals?
So dogs. I have 2 dogs.
Okay, there we go.
making this up.
No, I'm not.
So you're linking all the different threads together. That's great that you're here. Yeah.
So I know vets, how they work is in the US it's like a US-based system. When you prescribe a drug to an animal, what tends to happen is if the drug is not suitable, they kind of go down the grey area where maybe some drug is not approved, they just give you that. So I think with animals, precision medicine can be incorporated a lot, especially the R&D sector as well, trying to understand how two different drugs or a drug in a cell for a dog with a particular disease, how it can be affected. So I think that's where the precise element of that come in. So I work on the upstream area where we develop R&D tools to kind of enable that.
Tell us more about this tool. How does this tool work?
So the tool is a microfluidic or lab-on-chip platform. So essentially what we do is we take cell in a drug and we put it downstream. So we put them into like these bubbles basically, and we try to understand the interaction of a cell and a drug from a single cell perspective, and from there you can get better diagnostics, you can get better data. So it's just like an infrastructure tool that sits upstream of precision medicine essentially.
Is this for humans or for dogs?
So for both human and dog. So at the moment I'm validating the human market as well, but the entry to barrier is so much higher in the human market compared to veterinary. Whereas veterinary we can get in much faster and we can make a direct impact.
Okay, so you can make a case with the dogs,
Yeah.
and then later on maybe move to humans.
Humans, 20 years down the line, so let's see, yeah.
You're talking about 20 years?
Yeah, for humans.
So that's a long time to work with vets, but sometimes you have to do it. Okay, what do people think about that? Will we just be spitting into a box? Are you off, Natalie? Give us a final thought before you go. What do you think about that?
I mean, I'm not surprised these things do take a long time, but I guess you've got to start somewhere as well, which is the important thing.
You've got dogs?
No, I've got 2 cats. I'd love to have a dog at some point in my life, but...
Would you submit your cat to precision medicine?
Yeah, I think so. If it's at a point where the research has been done. Yeah, I mean, same with humans, I guess, right?
Okay, so start off with the dogs, then maybe move to the cats, and then maybe move to the humans. Have you got this for cats as well, or just dogs?
No, I'm just looking at dogs at the moment, so no, not cats, not yet, one day.
That's why she's gone. Yeah, but anyway, maybe later on we'll do cats. Okay, so we're, yes, point over here.
I work at London Zoo and we actually have the same list, but the animals are much bigger and there's nothing specifically prescribed to a giraffe or a zebra. So you have to go to the closest thing that maybe is in veterinary care, and then you just work your way down, and then
So
you've got
the
human
medicine
medicines.
for a giraffe is very imprecise. It's not even species specific.
Most of the time.
What do you mean by imprecise?
Well, I guess that's the question. What do we mean by precision?
Yeah, well, at least get the species right, I suppose. Any thoughts?
Yeah, I know I was the one that brought up the precision medicine. It's more like personalized medicine. Yeah, personalized.
Can you personalise it to a giraffe?
It has to depend on how the giraffe responds to the treatment. So if it responds, let's say, not in a beneficial way or what we expected from a particular drug, then you have to change to another. So if drug A isn't as effective as you wanted, then drug B is effective. Then it shoots the subject at that point in time. That is, it's being personalized for it. Yeah. So that is just getting what works best for a particular target. So that's the personalized part of it, and the precise part of it we're talking about.
Okay.
So is that precision medicine or personalized medicine? Yeah.
So a drug might work for one giraffe, but not another giraffe. However, potentially with Anu's lab on a chip, maybe London Zoo is a good place to start bartering your wares if you're willing to expand the species out of dogs. 2 giraffes, for example. I mean, what are the animals that get sick the most?
Oh, I don't know that. We have a vet team and they all have constant checkups. They all have constant checkups. But we also do post-mortems on all of them to understand why they died, and then we incinerate them.
Yes.
No, but we were talking about trust before, and you know, do patients trust the doctors or even scientists? Can you trust someone if you don't understand what they're working on, how that's relevant to you? But I'm thinking about dogs. Like, dogs are known to be very trusting animals. do they know what's being done to them? Do they feel like they're contributing to something? I mean, is there some kind of like validation system, you know? Because it's just a small story. In the Second World War, I'm from Poland. Polish army was in Syria at some point, and they picked up this bear, and they roped him in to serve in the army. And the bear got a statue out of it. It was carrying very heavy missiles and stuff like that, so they taught him how to smoke cigarettes and stuff like that, which I don't think that was that good. But the point I'm trying to make is this bear was contributing to greater good through war, as weird as it sounds, and it was recognized. So what about all these animals that are being, furthering the scientific research?
That's what I wanted to do. There's actually a Memorial Day, like we have, what's the Memorial Day?
Like a zoo.
For all the animals that died in war, in the UK. So and I think they've got a purple flower. So when you wear a red flower, it's a purple flower for all the animals that have died in war. But also, rats are used to detect landmines. Animals are used all the time.
So we're talking about the use of animals. We've got the precision medicine thing, but we've also got the animals. Maybe we're talking about precision medicine for pets. Have you got a pet? No. Okay. Have you got pets?
Nah, not yet.
No, I'm not a fan of animals, honestly. No.
All this effort about animal medicine is wasted. Should it be directed more towards humans, would you say?
Yeah, because animals can be used as the basis to actually know if the medicine is working or not. Yeah. Because obviously we can't use human beings as we can use human beings as clinical trials, but there should be real basis for using human beings. Because we don't want to cause any havoc to human beings, so it's best to use animals, and especially animals that share most similarities with humans, like the pigeons, the rabbits, those kind of animals. I think they really help, to know what's actually on the grounds, so that the real application can be done on the humans.
Okay, so we use animals to test different things, especially pigeons and rats. What do people think about that? Are animals a good way to test medicine?
I think they are, because you don't have to worry about kind of patient experience or anything like this. You just give it a treat, take it out for a wee. But with humans it's much more difficult. There's more at stake, and you have to, you can't treat people like objects in that sense.
Pets don't have lawyers generally. Okay. What's that?
Well, there's is Planet Earth. Yeah, it's got a lawyer or a firm. Yeah.
Environmental lawyers.
Okay,
I think there are lots of different environmental lawyers. Yeah.
So Planet Earth has got lots of lawyers apparently.
What about scientists?
Scientists? Are there any? Oh, we've got Earth scientists, I suppose, haven't we? Yes.
Apparently, so every doctor has to have insurance in case they go wrong. And apparently, it's obviously a share of your earnings almost. And I think someone was telling me that their friend is a consultant gynecologist and their insurance is at £100,000 a year.
Wow.
But they obviously make so much more than that. That's fine. But also, if you mess up, like you take someone's ovary out and they can no longer have children, like that, there's high stakes. So their insurance costs are high, but their income is also probably pretty high.
Okay. Have people around the table, have you got insurance? Are you clinical people? Are you scientists? Do you need insurance? We've got PLI insurance, but it's only more if we accidentally electrocute someone or there's a fight. I mean, that's the only real risk that we've got. But
yeah, for us, we are in the lab and we don't really have patient contacts.
Yeah.
It's just the samples we work with. Yeah, the samples they are patient, but direct human contact we don't actually have it because we're in the lab. Yeah. So the insurance part of it, I don't think is something that I don't think it's needed.
What's the biggest mistake you can make?
The biggest mistake you can make, I would say, make use of tiny tubes and all of that. You can just misplace them.
Okay, so
but once you misplace them, Once you probably put in the wrong tube, you have to discard everything and start from zero. You have to start all over. So just...
Anu, just give us a final thought. Give us a final thought. Yeah, but...
So once you notice any error, you have to start again, like afresh. So at the end, very, very careful. That's why they say attention to details is something we need to always have in mind, and also remain focused.
Wow.
So that's it.
Samuel?
So I think essentially we'll have lots of checks to prevent that. With like quality checks involved before you do a transfer and stuff like that at very critical stages in the lab process.
How do you do that? Can you just explain?
So for example, if I want to like transfer a sample from a tube to another, I'll label both tubes and do a self-check and get an independent checker. Yeah.
Do a demonstration.
Yeah.
Let's say I'm working on something.
Yeah.
I need to move this into this tube. Before I move it into the tube, he has to check it.
Right.
To ensure that whatever details I have here, the protocol runs, I move it in here.
Yeah.
So for him to do the check, he must have been trained and signed off on it. So he has to confirm like a double pair of eyes for me to ensure this goes in here and not this one.
Yeah.
So before I proceed, he checks. This is for this and not this into this. So he signs off, then I continue. Yeah, that's basically what we do.
Apart from that, that's before the process. Then we also have like at different stages to confirm that the data reflects one patient. So we have like some, for example, like there's a technical QFPCR, like quantitative QFPCR.
Right, okay.
Yeah, so essentially we'll be able to check whether that sample belongs to one patient.
Yeah.
And there's no cross-contamination at any point in time. So it means before the procedure, during the procedure, and after the procedure, we have well-validated techniques to ensure that we are giving the right result to the right patient and even at the right time.
Do you work in the same lab?
So work in the same lab, yeah.
Do you work in the same lab as well?
No, different lab. So I want to ask a question based on what we are discussing.
Yeah.
So what happens if we have two patients having the same name, the same date of birth, and then we have to transfer maybe samples from one tube to the other? How do we do that check? Because in such scenarios, it's going to be very difficult, you know, and we have to make sure that we don't end up like cross-contaminating those particular two patients. So, yeah, how do we go about that in such scenarios?
It's quite simple. First of all, we have a minimum of 2 identifiers for each patient, which can be more. So if they've got the same date of birth and the same name, which means they are going to have the same initial, so we can introduce a third one, which could be the NHS number,
right.
Or which could be something else. So there's always something to distinguish one patient from another. Yeah.
Okay.
And for the immediate workflow, no two patients have the same sample ID.
Yeah.
Each number is unique to it. Even if they share the same date of birth, the same name, the sample ID registered in the lab will always be different.
Yeah.
So we use that as an identifier.
Yeah.
Even the same patient, but different sample has different ID in the first place. So it's something really easy to like achieve within the lab workflow.
Yeah. I've got to say,
okay, so it's basically looking at the unique identifiers. Yeah. Okay.
Okay, so there is a lot of checks and balances to not make a mistake. I'm wondering if we should do the same tricks with our data transfer, because we're often accidentally deleting our footage. Hopefully we won't do it with this footage, but you never know. Maybe I need to look over it and you need to look over it. We'll have a double cross-check. Okay, we'll have a quick, we're getting some interference. Okay.
Oh, it is. Yeah, maybe we need to.
Okay, take you with this one. All right. Welcome. So we're doing a quick selfie, so you've come at the right moment. Right, okay. Okay, we'll take this go. Hang on a sec, before you go, give us a final thought before you go. Where would you like this conversation to go to? What do you think the big subjects are going to be, apart from precision medicine?
I think apart from precision medicine, everything that has to do with human involvement, I think more awareness needs to be made. More awareness. People need to understand the processes involved. In that way, it removes a lot of pressure from those who are really involved. Because when people not have an idea about certain things, it's easier to have maybe two-way interaction on it. I think more awareness gives more impact, more education, and everything. Yeah.
Okay, so involve the human more. Samuel?
I agree with him. I'm of the opinion that if you're caring for someone, the person should know what kind of care he's receiving. So I believe patient-centered care.
Understand what you're doing in the lab,
Yeah. I'm of the opinion that the patient needs to be more involved in the kind of care they are receiving, so that they can understand it, and that way they'll be able to receive it, give their consent, and it will be a reality. So apart from that, I also of the opinion that a lot of bodies, like regulatory bodies, need to be involved. The government needs to be involved. Everyone, like I said, all hands must be on deck on this matter. Yeah.
Okay, so let's get everyone involved. Jeffrey?
So I also think that good quality management systems should be put in place in the lab. Systems like training, like lab technicians, on a regular basis, to keep them up to date and make sure that they are competent before being signed off to do other technical workloads. I also believe that documents should be well controlled and managed in the laboratory settings. Yeah, and I also believe that people should be made aware and know the consequences of doing things wrong, like in the laboratory settings, so that they will all contribute to making precision medicine accurate. So yeah.
Thank you very much. Thank you, thank you. That was Ikenna, Samuel, and Jeffrey. We've got a lot of insight about life in the lab. Yes.
I wonder whether you have to be kind of like a risk-averse person to work in the lab, because you're not really interacting with real people. And if you are kind of this human interfacing jobs, they're just automatically more risky. But what you were saying about the insurance, are people insured, how much they pay? Apparently, this is what I heard in Poland, and I don't know about other countries, but apparently more students are choosing medical professions like a dentist, where stakes are quite low, and less people are going into obstetrics and things which are naturally more risky. People just don't want that thing on their conscience.
Okay, so are we becoming too risk averse? Are the stakes too high? We've got a new face.
Eva, hi.
Eva, welcome. I'm going to hit you with a round of applause. You can barely hear it, but trust me, it's a round of applause. If you sat there, you could hear it. You want to say something?
Two things. We find that funny that young people are making the decision to be risk averse. Because I feel like when you're younger, you are more risk taking. So I find that surprising.
Are you more of a risk taker?
Yeah, you just don't really think. I didn't think about authority too much as an issue. Didn't think, if you say something to someone senior, what's it going to do? And then as you get older, you're like, oh, actually, that could really impact my professional development. And so I am surprised by that. And then the next thing I want to say is, you just said the stakes are too high. I wanted to work at a butcher's, but I couldn't. The stakes are too high.
We've got the joke workshop. Isn't it Yeah, that's definitely. He missed out the crucial line that I wanted to work out butchers, but I'm too short, and the stakes were too high. But anyway.
I was going to say, in order...
Come and join us. Yes, this is Talkaoke. This is the time. This is it. I'm going to hit the theme music. This is Talkaoke. We have got Margot. We've got Lucy. We've got Eva. I'm Mikey. What's your name?
Emma.
Callum.
Inaya. Chichek.
Chichek. And I'm Mikey, and this is Talkaoke Free From Talk Show. There's a few different subjects we've been talking about on the table of chat so far, but you may or may not know that Talkaoke, it's up to you to decide what you want to talk about. My job is simply just to spin around and look excited about what you're saying. So yeah, I'm doing that. So you've got to do your side of the bargain. What do you want to talk about? Any thoughts? Ever is also open to you. What do these buttons do?
What's the situation with the buttons?
Okay, well if you say something.
Hello?
Hello, that's okay. Okay, say something.
Goodbye.
There we go. Okay. So that's the buttons. You can do the buttons. This is the most important. This is the most important button, which is the stop button. Okay, so we've got the buttons covered. Have we got a subject? Earlier on we were talking about precision medicine. Is it better for cats and dogs because you've got less risk to take? Are we in too risk-averse a world? Are the stakes too high, especially for short people, short butchers? And then, yeah, come and join us. We have got Chichek, Anaya, what was it? Callum, not really.
Emma.
Emma, that's right, and I'm Mikey.
Tabara.
Yes. We've got Eva, we've got Lucy, we have got Margot and Mikey, but we are a bit stuck for a conversation because we don't really have a strong theme at the moment. I mean, there's a few things we're talking about already, but I feel like we've got a new cohort of people, but not necessarily a subject to talk about. Have anyone got any thoughts on this? What would you like to talk about? What brings you here to the FOG, Festival of Genomics and Biodata, but everyone forgets the biodata, even though that's mostly what we talk about. Are you genomics, biodata, neither? Callum?
We're genomics.
Genomics?
Briefly, we do cancer oncology work in breast cancer.
Okay. Did you say oncology or ecology?
Oncology.
Okay. All right. So are you oncologists?
Yeah, I guess so.
That's, and has it been useful for you so far?
Yes, it's nice to see some presentations from our research institute.
Okay, so you've been to your presentation of your own research.
Yeah.
Thoughts? Any questions? Come and join us. Come and join us. I mean, we've got some oncologists around. Oh, you're off again.
We're off. I'm so wait.
Okay. What's the future of oncology? Yeah, definitely.
That's a big question to ask.
You're leaving.
That was a mistimed sound.
Oncology, is it going to be?
I think precision oncology, like targeted treatment, hopefully.
How precise can you get in oncology?
Very precise.
Very precise.
Genomics level precise.
Genomics level precise. Okay. Well, thanks for joining us, albeit briefly. Maybe the challenge was too great. Maybe we should have just hit that group with an ongoing conversation rather than. But I thought they'd come up with something. Anyway, where are we going to go with this? Yes.
I mean, is it still the case? You know how people always say, like, oh, you know, but you're not exactly inventing a cancer cure for cancer. That always seemed to have been like the, you know, the benchmark. We're talking about high stakes. Still running with that because I think it's a meaty conversation there. But that's always been kind of held up as a kind of the ultimate, like, holy grail of, I don't know, medicine. Is it still that, to find a cure for cancer, or is there something higher than that now?
Is there a higher goal than the cure for cancer?
So I think this is where precision oncology comes in, because it's not about one cancer. There are so many different types of cancer, and some of the things that precision oncology does, it will look at the DNA of the cancerous growth and compare it to using whole genome sequencing to the DNA of the actual person and try and work out what are the changes. This says a lot about how an individual person can be treated, because and whether certain treatments are a complete waste of time on that person, whether they're going to cause more harm than good. So it's not so much about one singular cancer or one singular treatment or one singular result. It really is just about what is the correct fit for that particular individual, and I think that's why genomics in relation to cancer is just absolutely the area to be looking at, because it really depends.
Yep. Okay. So every cancer is different. Cancer is just a catch-all term for all those different. If we had to come up for a name for every cancer, we'd be here all day. But with that level of difference and diversity, we can also have a different and diverse treatment regime for each one. Does it give you hope for the future?
I mean, I don't know, but it's definitely making me think of something, you know, when people talk about medical research and stuff like that, I always think of, I mean, I've always been thinking about people as just like, you know, sample givers, you know, it's like a generic group of generic people, but I think we live in quite individualist times where it's not, you know, it's not just about using no, I don't think anyone really uses humans to kind of, or maybe they do, anyway, but I think we live in such individualist times that it's no good finding cure for cancer or whatever, but it has to be like very specific, very bespoke, and very individual in a way. So that's the really big challenge, to create something, a bunch of things which are, you know, very precise to, I don't know, maybe suitable.
Are you saying that this kind of precision medicine is a kind of consequence of the individualism of our society, that we all have to have our own cures rather than a generic cancer cure, which would be...
I never thought about it like this, but maybe yes. Maybe that's a natural progression, you know. I mean, it is probably just a natural progression. You want to get more precise because you appreciate people for the individuals that they are. But, you know...
I think it's more biological than that. I don't think it's individualism because of societal pressure. I think it's individualism because that is the only cure. When I say cure, treatment, prevention on an individual basis, because we're finding out that old terms like cancer with capital C, that somehow was all cancers, isn't accurate really. And so that the more we find out, I think it was a kind of umbrella term, it still is an umbrella term, there's so many other things below it. You were talking about taking samples from people, and you were talking about that in really quite kind of broad ways, but I think that I think if you or a member of your family have suspected cancer, then it's not about, and that's the majority of people who are giving samples, then it's not about an abstract group of people giving samples. It's specifically about what you can find out about the DNA of a condition that you've got, and it kind of shifts it into a completely different terrain.
Okay, we've got a new face at the table. So we've got Margot, we've got Lucy, we've got Eva. I'm Mikey. What's your name?
Zainab.
Zainab.
Yes.
At the moment we're talking about precision medicine. Is it the future? We talked about cancer. Every cancer is different and requires a different precision treatment. Can we get there? And is that level of precision and individualism just the way we're going in the world? Is that a good thing? Maybe it is for cancer, but what about other stuff? That's what we're talking about loosely here. Have you got any thoughts on this, Zainab?
I know it's a huge space. I know that it's the biggest, hottest topic, with the likes of FMI kind of taking over this market right now. But I think it's also, it can easily, in an unregulated environment, be a bit uncontrolled. Yeah. That's my personal opinion. I think there's obviously issues with data consent and what's done with that data. And I think as people gain more knowledge on the impact that their data can have within the world and how it can be used think that's a huge reservation that people will have. And I also think the one thing that I think about is it too much information? And is it TMI? Is it too much information that we don't necessarily need? Or
I mean, earlier on, earlier on we had some data. We have a lot of data people come around the table. They're hungry for data. They don't believe that there's such a thing as too much information. That's them. But maybe other people have got other views.
I'm just wondering, are you talking about a kind of polygenic risk score type scenario where you are basically assessing the propensity of an individual effectively to develop a type of cancer, a kind of rare condition, or are you talking about post-diagnosis, the ability to analyse, do whole genome sequencing or what have you? Because I think it's quite different positions in terms of both data capture, the data controller, and also what you're doing with the information. When you said it's too much information, that seemed to imply that we're looking at a polygenic risk score type scenario. Is that right?
yeah, I'm kind of curious to see where you see this fitting and where you see the best use cases and how it should be adopted.
If it's kind of precision, if the question is where I see precision medicine generally fitting, then it is rare and inherited cancers, rare and inherited genetic conditions, and it's about both diagnosis and kind of trying to find out things like kind of long read sequencing and seeing what variants of unknown significance are affecting a condition, can affect what is the best treatment outcome for a patient. I think it's, as you said, a huge space, a very exciting space, and I'm excited to see people are investing in this space, and I think we need to see more investment and things moving even faster.
From the polygenic risk score and the sort of uncertainty, when you've got information, it's not the same as knowledge, and so there's always going to be a gap between possibilities and certainties.
So that's part of this kind of NHS England 10-year plan idea that you're actually predicting, rather than it's a prevention rather than treatment. So it's kind of rolling out to the general population. Some idea that you're trying to do is get a sense of who is most likely to be affected by cardiac conditions, by these kind of conditions. And I think there's a place for that. And you're right, it has to be informed consent. The most importantly for me is it's not just about getting that research done, it's about having the structures to explain what this score means to someone so they don't completely freak out if they realise they have like a slightly higher risk of something. For me, that is one stream, one avenue. It's a really interesting one, lots of ethics issues there, as you rightly point out, but I think it's a slightly different, we were talking about risk, it's a different risk kind of level to rolling that out for a population which has already been identified as having high risk, or actually even more than that, family members or themselves have been identified as having conditions, and we were actually doing the precision medicine not as a predictive, preventative, but as a kind of treatment.
I mean, we can go in any direction you want to go. It's up to you, Zainab, Eva, Margot, where you want to take this. But I mean, there's so many questions. It's almost like we could be speaking all year. So it's up to you, really. Do we want to talk about the ethics of this, the risk, or there's a really good point about we don't really have a structure of how to explain these things to just the general population or patients or anything. So it's kind of up to you. Where do you want to take this conversation? What element of this do you want to pick out and focus on? Zainab, have you got any thoughts?
Well, I was kind of just listening to what you were saying, and I think the barriers for adoption and the barriers for implementation kind of countrywide, I'm kind of just interested in what you think. Obviously, we're talking about things like ethics, but also things like training. But what do you feel those are, and how do you think that we can kind of come in and mitigate those, other than from like a funding perspective?
I think it's about education, and it's also about it depends about specifically what we're talking about doing. But if we're talking about, for example, gathering DNA from people as a preventative to give them that score, then it is about having a really robust structure there, both for informed consent, to explain to them what exactly is happening, whether they are happy to receive results that might be negative but are vague. So for example, something that says you have a 50% chance of getting this, but it's vague, or even, quite frankly, some people prefer not to know if they've got a rare condition, if there is no treatment, and if it's a rare condition that will even potentially lead to some really negative outcomes, but not for a long time. Some people want to know, want to be active in that space. Other people would rather not know. And it's not just about themselves, it's also about family members, because, but also, family members, but assist, like if it's a genetic condition, there's all sorts of complicated sort of moments where a sibling might not want to know if it runs in the family, because then they are themselves affected. So you get over. So it's the whole sort of ethics space. Yeah.
Okay. Maybe just go around the table. Just simplify this a bit. Would you want to know if you had an untreatable rare disease, or if someone in your family had it? Would you want to know?
That's a very good question. I'm not sure. I mean, my mum's a smoker, so she's been smoking all her life. And then when she was a little bit concerned about her respiratory function, she's like, you know what, I don't want to do too many tests, because if there's cancer, I just don't want to know. And I was like, that's just so dumb. Like, you can just why wouldn't you want to know? But I can understand. She's towards the end of her life. It's like, does she want to know? Does she want to have that extra thing to be worrying about? So, but if it comes to like uncurable disease, I really don't know. Maybe I wouldn't want to know, but then I'd want to find out. You'd want to find out, but you wouldn't want to know the answer. It's such a strange.
So you want to find out, but you wouldn't want to know. Okay, that's interesting. I mean, we can do that on Talkaoke. We can have these positions. Lucy, would you want to know?
I'm not sure. I've been racking my brains on it as you've been asking it, and I don't know.
Don't know whether you would want to know. Okay.
I would say I've been doing a lot of research within neurology and specifically in Alzheimer's, and I've seen that 93% of people with a predisposition or with slight symptoms of Alzheimer's would ultimately want a diagnosis, even if they don't know, even if there's not a direct line of treatment, because having that disease ownership leads to them being able to life plan, family plan, try and reduce their risk factors. So I think from that perspective, I think it's kind of changed my perspective as well, because I think initially I was on the stance of I don't actually want to know, but I think I now see a lot of disadvantages of putting a name to something from a disease ownership perspective, and also from a control perspective, and a management perspective. And also, I think if I was feeling things, it would make me feel better to have something to point that towards. So if I had
to understand what's going on.
Exactly, but obviously that is a lot harder said than done, is knowing something and knowing that there's no cure for it. But yeah, I think I'm more on the side of that side.
Some experience of talking to, are these patients with possibly with Alzheimer's or definitely with Alzheimer's?
Possibly with Alzheimer's.
Okay, so you're saying you've got a high risk factor, but we don't know if you've got Alzheimer's at this point. Okay, you joined us. We're on a bit of an ethical kind of turn here. We're talking. Ever brought up the subject? If you had a rare disease which came up in your genes, would you want to know about it if there was no treatment? And we've kind of like thought about it ourselves. Most people would say no. But Zainab works with patients that possibly have Alzheimer's, and saying yes, that is actually extra information, even if there's no treatment or cure. Everyone?
No, you didn't. I would want to know every time, and I think there's multiple reasons. First of all, just because there's no treatment for it doesn't mean there's not going to be a treatment for it. And and there's the kind of the personal reasons I want to know, but there's the sort of more communal or society reasons I want to know. If you don't know how big a patient body is, you can't develop a treatment. So then, you know, say you had something super rare and it was only 5 people in the whole world. Those 5 people desperately need more people in order to develop a treatment. If all the people who had that condition didn't want to know or didn't want to engage with it, then there won't ever be enough impetus to fund that treatment. So, you know, even if you just know and clock it, you know, go and see someone, get some mental health, and allow yourself. I know that's very easy, and I respect the decision that other people make that they don't want to know. But I think there's almost, if you are mentally able to do it, there's a social responsibility element to knowing.
Okay, so it's an emphatic yes, not just for you, but for humanity as a whole. So we're talking about, first of all, we'll get some names. We're talking about, I think I'll just explain what we're talking about, but we've got Zainab, we've got Eva, we've got Margot, we've got Lucy and Mikey. What's your name?
Christoph.
Christoph. I mean, I know you've just come into this discussion. Would you want to know if you had a rare but untreatable illness?
I'd say so. I would definitely agree with the social responsibility. It's something like 17% in the keynote was mentioned of people have some sort of rare disease. So especially with rare diseases, we should all be more aware of the fact that we might be carriers for a particular variant that makes us more susceptible for a rare disease. So that will build up awareness on a global scale, prompt engagement in research, in that it's not just someone else out there. It could be a descendant of ours, which will help people to have more of an emotional connection with it. And also it should build up awareness of how genetics really works, that associations don't necessarily mean that one is going to get something, that most diseases are polyvariant. There are going to be all sorts of influences on that as well. So it's also beneficial in terms of rewiring the way people, wider public thinks about genetics, in that there's a lot more to it than a particular mutation in a particular gene that damages the product and then you're going to get disease X, Y or Z.
So you're also talking then about kind of culture shift where we just change our perspective a little bit, and it's not just about me, but it's about us. But also that kind of like, there is a bit of uncertainty there as well in terms of how the actual phenotype of a particular mutation actually comes out. We don't know sometimes. So that's another point as well. Come and join us. We're just talking about if you had a rare disease that we found, rare condition.
I think prefer condition to disease. Disease is quite loaded and it doesn't necessarily, I think you've already stacked the question in a particular way when you use the word disease, whereas if you use condition, I think it's more open-ended.
Okay, all right. If you have a rare condition that is untreatable but has been discovered, would you want to know about it? That's what we're talking about now. We've gone around the table. It's a kind of maybe no, emphatically yes. After having talked to Alzheimer's patients, yes, and yes. So, any thoughts? Let's tell us your name as well.
Yeah, my name's Sam.
Sam, welcome. We've got Margot, we've got Lucy, we've got Eva, we've got Zainab, we've got Christoph.
That's a great memory for names. I mean, I think it is a very personal decision, and I think everyone would have different answers to that. It needs a lot of thought about if you're talking about a specific condition, whether there are adjustments and things that can be made, even if it's not treatable. Are you talking about something that might affect career in the long run, career options, driving, all sorts of other things, the risks of having children, you know, or your ability to be a parent if you have children as well, like, and there's a lot of factors to consider, not just treatment. As a kind of like a blanket yes or no, I think I probably would want to know, but I would also want the nuances of that particular condition to think about it in a bit more detail, I guess.
I think that how you kind of pivoted it, Eva, as well, talking about some kind of like a social responsibility almost, because it'll be very hard to make a case for your particular condition if other people are not coming forward, if they kind of internalize this, like, oh, that just happened to me, well, I'll just deal with it. Because there is hope, and as you were saying, you know, maybe there's no cure for it or treatment for it right now, but there might be. And I think, you know, it just breathes new air into this whole experience, it seems to me. But yeah, the social responsibility, it's an interesting point. I'm thinking about it. Yeah.
Okay. Yes.
I was just saying, it's sort of balancing that feeling of community and like, you know, like feeling like you've got people who you can relate to who might have the same symptoms as you, the same condition overall, versus also then the very real stigma attached to some of these things, even though that stigma shouldn't be there. You know, people from certain backgrounds and cultures, communities might feel very differently about being open about a condition, about knowing about the condition, about what that might mean to their family in terms of reputation and things, and it's a complex thing to think about.
Yeah, it's definitely a very complex question.
I think building on that as well, the idea that somehow you don't know is somehow that you're not affected in some way, because if you are affected, then you might want to have questions about you know, what's happening to you, why is this happening to you. It may be, this conversation started because we were thinking about, well, one of the things we talked about was the NHS 10-year plan. We were looking at polygenic risk score. I'm also thinking about things like the newborn study, which is looking at about 200 conditions, and one of the criteria is that they're treatable, because that's the other kind of question mark, is that if it's treatable or if it's not treatable. And so the idea that somehow you could not know seems to also be around this idea that somehow you would never know. Like, you've made a decision, you're not going to know, and now you're never going to know, and it's never going to affect you. And the reality is that really, if you choose not to know, maybe you're only choosing not to know now. And in 10 years' time, you're going to have to find out in a much more kind of like cliff-top way.
There's also this question, I think, that you brought up, Sam, about community and the onus of, are you off, Zainab? Give us a final thought before you go. But let me just finish this thing about the onus of medicine not being on the individual, even though we're talking about precision medicine, but being on a wider community, or somehow there being some kind of connection with the community when it comes to medicine. It's not just about the individual, because the diagnosis always is focused on a single individual. But anyway, Zainab.
My final thoughts are just, this was a really interesting discussion to be a part of. From an ethical standpoint, from a future forward thinking standpoint, and from what's currently relevant. And I also think everyone's insights brings their own lived experiences, their own backgrounds, and yeah, just diversity of thought is very much welcomed here, which I like.
Because you work with potential Alzheimer's patients, are there cultural differences in how they're kind of used?
Yeah, definitely, and I would say even looking away from Alzheimer's, but obviously I'm a Pakistani woman, and as you mentioned earlier about stigmas, there is a lot of stigmas around, for example, cervical screening. And that's a huge thing that we are currently working on as well, is how can we target specific communities of people to go on and get diagnosis or get their screenings done. And stigmas and family backgrounds plays a huge role in that. So yeah, that was a really interesting point as well.
Okay, that's a big one. Yep.
I've got an Alzheimer's related question which you may or may not be able to answer, but I've heard, so you know, it's going to go well if it starts like this. No, but apparently if you floss your teeth, bear with me, it decreases your chance of developing Alzheimer's, and the reason being is because the nerve endings in your gums, if they get inflamed, if they get, you know, if they're not happy, then that somehow kind of wiggles its way to the brain and deteriorates the brain. Discuss. I've heard it from an Alzheimer's charity person. They were working.
I think I heard something similar, but it was about the bacteria in your mouth if you didn't brush your teeth enough. So I don't know what's going on. I heard something about the bacteria in your mouth can have a negative effect. Have
you guys heard that?
Is it true? Is it dental propaganda? That's what we'd like to know.
We don't know. But have you heard about smoking? Smoking could be preventable to Alzheimer's disease as well. What? You might develop lung cancer, but you may not develop Alzheimer's. So I'll leave you guys with that.
As if we haven't got enough bombshells. So where do we want to go with this? Do we want to talk about the Alzheimer's? give us a final thought. Eva, thank you very much for your contribution so far.
Yeah, I like your rugs. That's my final thought. Did you bring them from home or were they here?
What it was is we came here and it was like very bare, like just over there, and it was just like, this is so bare, it's so clinical. We want to almost rather be the carpet, especially when you've got things like this very illuminated sign and video screens. We thought we'd go for a more kind of like, you know, a more homely carpet shop sort of vibe.
Well, this is the flying saucer of chat, so that's the flying carpet of the flying saucer of chat.
Okay, that was the...
Thanks so much.
Oops, wrong button. Anyway, okay, where are we going to take the conversation? Thank you, Eva. Where are we going to go with it? We need to get... Yes, we've got a person coming in, yes. One out, yes. Okay, so... Well, what I will say, this is Talkaoke, and there's no contractual obligation whatsoever. You can stay as long as you want. You don't have to say anything if you don't want to. You can say something completely irrelevant. But I challenge you, I challenge us to find the relevance. Anyway, my name's Mikey. We've got Margot, we've got Christoph, we've got Sam. What's Hannah? Hannah. Sorry, Hannah. And yes, Christoph, you wanted to say something, or was it?
I wanted to say something. No, but I was just wondering, like, we were just joking about this dentist propaganda, but I mean, is there any, yeah, sorry, it was...
So basically, there's this idea that if you floss or clean your teeth or do some sort of oral hygiene, it's going to improve your chances of not getting Alzheimer's. But apparently also smoking reduces your risk of Alzheimer's as well, but they keep that quiet because they don't want people to start smoking. Yeah.
Okay, so smoking is good for not getting Alzheimer's.
Yeah.
Okay, well, good to know.
Yeah.
Good to know. No, but my question was like, are there any kind of other sources of, I mean, is there some kind of propaganda in your line of work? What I mean by that is, are there certain, I don't know, areas of research or methods of work or whatever, which are more preferred? You know, is there some kind of like a trend right now in, I don't know what fields you specifically work in?
So you're saying, what's the hype?
Yeah, what's the hype in your area?
Okay. What's the hype in your area? That's what we're asking. Come and join us. Yes. Yes, you can. Anyway, Christoph, what's the hype in your area?
Going back to the thing about the dental propaganda for a bit, I think they just took removing plaque a bit too seriously.
Yeah. Okay.
But beyond that, I think in genomics, in genetics, I think there's a lot of hype about single cell RNA, single cell sequencing, single cell this, single cell that, whilst what we know about biology is that if it only happens stochastically in a small population, then it's probably something that happens stochastically. It's not something that has real biological meaning.
Yeah.
So people are underestimating the value of bulk experiments stratified by, let's say, cell type, cell state. And everyone's going single cell.
Yeah.
Whilst I'm an epigeneticist, I work with DNA structures. Let's say if they exist in a state of flux where you've got 50% of the cells having those, 60% not, then it's either you've got a read saying yes or a read saying no, and that's not how they function. So I'd say single cell, everything having to be single cell.
So you've got all cells out there doing their own thing, and they're not. Come join us, yes. So we're talking about, is there too much hype around the single cell analysis when some of those cells could be doing any kind of crazy stuff? Which it's up to you. Do you want to answer that question, or talk about the hype in your area?
I can't think of any hype.
What is your area? Have you got an area?
I'm a genetic counsellor.
Okay. We needed you earlier on. We needed you because, I'll tell you why, sorry, it's just because we were saying, we've got all this information, but there's no one there to deliver it, make sense, give context to the patient. You're here. You can. Well, we needed you earlier on, basically.
That's what genetic counsellors are there for.
Yeah.
So, like, you know, it's about, I guess, if I get very nervous when I've got a microphone in my mouth. But, like, I guess if there's information that people need to hear and it's not being delivered in a format that's very explainable, that is literally what the role of a genetic counsellor is, to make it understandable to the people who it relates to.
Yeah. Okay. What's your sort of toughest job then? I mean, obviously it's a tough job anyway, but what's the hardest part of your job?
My current job is population screening for couples who may be at risk of passing on conditions to their children, but things that they don't know they have. It's recessive conditions, and feeding back a diagnosis like saying your future children would have a 1 in 4 risk of cystic fibrosis or Tay-Sachs disease or something when there's no family history at all, and kind of having to explain how that has come seemingly out of the blue, and that is going to have a massive impact on someone's decision about whether to have children, how to have children, how to have healthy children.
Okay.
So yeah, that's definitely the hardest thing about my job at the moment.
Quite a tough job, I've got to say.
Genetic counselling gets a lot harder than that in other areas.
Maybe that's why there's not enough genetic counsellors. Maybe it's just too tough a job. Hannah, have you got anything to add?
What about the hardest part?
Yeah.
Just thinking back to like when we work together, I guess it's, you know, when a patient comes in for one reason, you know, maybe they've got one problem, and then you order genetic testing and it turns out that's just part of a wider syndromic problem. So, you know, actually going forwards, they're going to start developing other problems. So for me, I think that was one of the hardest. Oh.
Okay, that's a big one. Yes, Margot?
This is just a glib point, but it reminds me of my hairdresser friend. When I started seeing him, I only wanted like a 1 blonde strand in my hair. Over time, because he was giving me mates rates, as you'd expect from a friend hairdresser. Gradually, I realized I'm getting blonder and blonder, and then what he did. So I was coming in for one thing, but I was just getting more. So you need more blonde here and there, and then he did the worst thing and moved to Zurich. And then I realized how expensive it is to maintain blonde hair. So I went back to neutral. So yeah, sorry, neutral? Natural. It's not transparent, my hair, luckily, but yeah.
So you come in thinking you've got like a cold or something like that, and then you go out with like...
What are we doing?
Yeah, that sounds tough. Christoph, what would you want? Would you ever interact with genetic counsellors? What would you want them to explain in terms of your research?
I suppose the main thing as an epigeneticist that I think is important to convey to people is that...
There should be special epigenetic counsellors.
I think that would be a great idea, but we just don't have that data, unfortunately.
Okay, well, there we go. You're an epigenetic counsellor.
But that's in the NHS, unfortunately, as we heard from the keynote this morning, they're focusing on trying to do whole exome sequencing, so just sequencing genes. But no one's too interested in sequencing regulatory regions, and it's those regions called enhancers that govern what a cell is, whether a cell is a skin cell or whether it's a white blood cell, because the genetic material is somewhat the same, except a few point mutations here and there that lead to disease.
I mean, do people need to know about this? Is it more of like a arcane scientific fact, or does it have an implication on clinical treatment?
I think it does. So let's say with blood disorders, a deletion of an enhancer it can cause your hemoglobin levels to decrease by 50-60%, sometimes even 80%. And that's something that's 50,000 letters away of DNA from the gene that's being regulated.
Okay, so it is need to know stuff, and it can have actual clinical effects.
Exactly.
It's not just a obscure element of study. What is your sticker that you've got there? The epigenetics?
Oh, I gave him a sticker saying I love epigenetics.
Okay.
I don't work in epigenetics,
Okay.
so
Would you like to work in is there a room for epigenetic counsellors?
yeah, I reckon maybe.
Yeah, I think maybe more in the future.
Yeah.
Again, at the moment, a lot of with epigenetics is less diagnostic, less specific. It's still an area that, as far as I'm aware, is growing vastly, but we're still in the very early stages of understanding all the regulatory stuff, and it's something that we are working a lot on in terms of the diagnostic,
Might be your phone.
probably, the diagnosis of rare disease. And yeah, I'd love to understand more about epigenetics. It's something I feel is a bit of a blind spot with me.
Okay, well maybe now's the time because we rarely get to talk about epigenetics. There was a bit of a kind of thing for it a few years ago, but then it kind of like faded back again. Are you off, Hannah? Give us a final thought before you go.
I love epigenetics.
All right, we've got a new face. We've got Margot, we've got Christoph, we've got Sam. I'm Mikey. What's your name?
My name is Jigang, but my English name you can just call me George.
George?
Yes.
Not Jigang.
Anyway.
Yeah. Okay. All right, George. It's up to you. What do you want to be called?
Jigang.
Gigant. Okay, all right, I'll stick with that then. At the moment we're talking about, there's a few things. We've got Christoph, our epigenetic specialist. We've got Sam, genetic counsellor. We've got Margot, person with a genome. And there's me, person with a microphone and a genome. So that's where we are at, basically. We're sort of talking about how do we deliver sometimes this clinical information to patients when they don't understand, and we've got a lot of work to do as a counsellor. But also we're talking about this, maybe people don't understand some of the related fields of science who are clinicians as well, I suppose. It's fair to say. So that's where we are right now.
Yeah.
But where do you hail from? What's your kind of area of
I'm exactly at the intersection of all of you, these people. Intersection, because I working into academia, but also my research related to clinical as well, and also I teach biological students.
Right. Okay.
Yeah, I'm at the heart.
Okay, so you're everywhere. Okay, so
yes.
Well, that's good. What I'm going to ask you the question I asked everyone. What is the big hype in your area at the moment? What do you think is the hype?
Great. Actually, I do blood. I focus on bone marrow, immune cells.
Right.
So my hype is, I believe bone marrow is a good hub to correlate with a lot of disease. There is a keyword I'm working on, key area. It's called clonal hematopoiesis. The clonal hematopoiesis can be used as early offense for blood cancer and also for a lot of chronic disease like cardiovascular disease and also some how to say that also like liver chronic disease, kidney chronic disease, even in your teeth chronic disease as well.
Yeah. Well, earlier on we were talking about flossing teeth to prevent Alzheimer's or brushing your teeth. Do you have any? Have you got any views on that? Is it a thing?
Brushing teeth.
Yeah,
it's good habit. It's good habit.
Good habit. But is it just dental propaganda to say if you don't brush your teeth, you're going to get Alzheimer's? Is that just propaganda, or is there any truth in it?
Yeah, I believe so. I believe so.
That's all right. Thank you for that, Jigang.
No harm in spreading that message anyway. What's the downside?
Okay, there's no downside apart from,
I don't know if I'm going to develop Alzheimer's, but certainly I have been to my dentist recently.
Yeah.
And prior to that, it's been 2 years since I've seen a dentist. And she said to me, it's all good. And she said, what do you do? How many times a day do you brush your teeth? She was trying to catch me out on brushing too often, but I know I shouldn't do that because my gums recede, so I wasn't born yesterday. But eventually I realized it was precisely because of flossing.
Okay.
So I'm a philosopher of flossing.
You're a philosopher. Okay, so all right, we can go. The whole point of Talkaoke, we can take this conversation anywhere you want to take it. We can talk about genetic counselling. We can talk about the intersection of all these different researches. We can talk about epigenetics. You were saying something about blood as well, weren't you? And you were saying something about blood, so we can talk about the blood thing. Yeah.
I have a question about epigenetics. You may not know, but what truth is there that personal trauma or family trauma can kind of carry through epigenetic and gene regulation and stuff, and actually have an impact on the formation of rare conditions and things?
Okay, yeah. That's the sort of chat that we often have on Talkaoke in a non-science thing. People talk about the personal trauma of generations having an epigenetic effect. Is there any truth in it?
There is that famous Dutch study from World War II that has shown the heritability of certain epigenetic marks, and even taking it back to a molecular level, we found that a single double-stranded break is enough to cause changes in how DNA is wrapped in the 3D genome across several passages, several propagations of cells. So even from that small scale to a population scale, there is evidence. But then there are also particular epigenetic marks, such as modifications of histones around which DNA is wrapped. We know very little about how that actually functions. There are a few dogmas, but some people are saying that the marks themselves they're just a consequence of something else happening, that there's not really much that these marks are responsible for themselves. So I'd say there's evidence for heritability of some events, but the mechanism of which I think we know less about than we thought we did before.
Okay, thank you for that. Good. I'm just going to get a final thought. Maybe there's some questions about that. We've got a new face. Tell us your
I
name.
don't know what's going on here. No, I just had to listen for a moment.
Just say your name.
Mia.
Mia, and see.
See what?
Give us a final thought.
One thought. I would say epigenetics maybe just like my code. It's more soft. It's the mutation is also frequent as well. So we are doing these things. Somatic mutation is slow, but epigenetic mutation
happen quickly. Yeah.
Yeah, that's my final.
Okay, so it's a bit of a faster thing. It's
faster thing.
Okay. All right. Well, thanks for that. I'll see you later. All right. Okay. Give us a final thought before you go.
What is epigenetics?
What is epigenetics? Good question.
Anything that is involved in DNA regulation that isn't actually DNA itself. So modifying DNA, how DNA is wrapped up, how it folds in the genome. So every single one of our cells is pretty much identical except for, let's say, cancer-driving mutations. But in theory, it's all identical. But of course, we have so many different cell types in our bodies, and that's all governed by epigenetics. So it's everything that is above the genome, that it's not the genome itself.
So it's what genes are accessible.
Exactly. It's how that's regulated, how which genes are accessible.
Okay.
All right, that will be my final thought.
That's not a final thought. That's an explanation. We want a final thought from you. What's the future of epigenetics?
This is such a lovely idea for bringing people together at such a conference, and also the design, I was thinking, really reminds me of, let's say, a Brighton vintage shop.
Yeah.
That's the sort of thing that I would expect, which I like. It's very cosy.
Okay, thank you. That's
a great observation. We were going for a Turkish carpet shop, but we'll go for Brighton. Brighton vintage, yeah. Well, thank you for appreciating our on-the-fly design.
Well, thank you, Christoph.
Thank you. Grab a card as well. We've got a card? No.
There we are.
Stay in touch. But yeah, so there's been, we even sometimes have themes for these conversations, but I completely forgot what the themes were supposed to discuss.
AI, but weirdly, this is the only time we haven't talked about AI. We're always talking about AI. Anyway, Mia, you're in still. You don't have to say anything. There's no contractual obligations. We've got Mia, we've got Margot, we've got Sam, we've got me, Mikey. Where do we want to go with this conversation? Do we want to talk more about epigenetics? I felt like Zhigang's point about epigenetics was maybe a little bit dismissive. He was saying it's like, if I'm the body, epigenetics is like the coat, he was saying. Come join us, yes, 2 minutes. We need your esteemed opinion. Yeah, any one of these could be yours. Okay, Sam, what are you going to say?
Yeah, I think, as with anything, there used to be the thought that anything that wasn't a gene within DNA was junk DNA, and that's all been, debunked now. I think epigenetics is going to be far more important than previously thought. We just don't understand it yet.
Yeah. As if genomics wasn't complicated enough. We've got epigenetics just to make it even more complicated. Come and make our lives more complicated. Come and join this table.
What's your background, Nick?
I'm a PhD student working on lumpy skin disease now, so virology and stuff.
Say that again?
Virology, so PhD student in virology.
Okay, how's that been going?
Pretty good. Just about the end of my first year now, so really good start.
How many years have you got left?
2.5 to 3, I guess. Yeah.
How many years have you got left in reality?
I don't know, hopefully 3.
Okay, hopefully 3. Okay, but it's going well so far?
Yeah.
Okay, and where are you doing that?
University of Surrey and the Purbright Institute.
Do you think you can ever get an AI genetic counsellor?
Oh yeah. I'm not saying they'd be very good, but absolutely.
Yeah. I mean, would that be the way ahead where there is, we've heard earlier on there's a lack of genetic counsellors. Could you kind of replicate Sam and Hannah as AI avatars so that more people
to some extent, and I think if you've got a genetic result that you need explained, I actually think that's something where AI can be quite useful.
Yeah.
If you find that you carry a particular mutation or something, I think to some extent there's a couple of there's nuances to that. First of all, the whole point of a genetic counsellor is not just to explain the science, it's to look at the person, their individuality, what their family situation is, make sure language is at an appropriate level for them, make sure that, you know, that you are, that there's a lot of cultural and social things that you have to be very aware of. And I don't think AI could do that very well. And I also think it does make some errors on the basic science level that it comes out so confidently wrong at times.
Okay, so it's a level of confidence sometimes that is a little bit, we've got a button for that.
I would almost be more worried about the lack of empathy and stuff when delivering difficult news, though, because you're dealing with things that could potentially trigger quite vast depression and all sorts, and you know, you need to make sure that is being handled in a sensitive way, and AI just can't do that.
Okay, AI can't be sensitive enough. Any thoughts on this side? Yeah.
I've heard that about language. And I think technology is somewhat to blame. This is not about genomics, but apparently some words are disappearing from our vocabulary, and they're almost purposely erased from from general popular use. And then, you know, you can't search for these words, or I mean, you can search. I don't know, like for example, words pertaining to borders or like limits. You know, stuff like that. It's a bit, maybe it's a bit abstract, but I think technology is kind of working, because you were talking about language, so how to talk about certain things, and AI is pretty precise and maybe a bit harsher, more direct, or something like this. Are we just kind of becoming a bit harsher? I don't know, maybe we'll be able to take that difficult, you know, these difficult points, these difficult...
Okay, so, all right, yeah.
I mean, this goes back to when I very first sat down, and that lovely lady there, I can't remember the name of, was saying she would rather something wasn't called a rare disease, but a rare condition, ever. Yeah. And I think that actually, you know, that is a conversation I have with a lot of people when talking about genetic mutations. You can call them mutations, changes, variants, you know, a faulty gene. And people have different stigma attached to different words, and you can't predict that in advance. Some people might sit here and say, actually, you know, my rare condition is a disease, it is a disability. Some people would say, I don't want to see it that way, I don't think it is a disability. And language is so personal, and AI just, you know, it doesn't yet have the ability to be that sensitive. I mean, you know, again, if someone says I'd rather you call it this, I'm sure AI would switch its language, but what it might not then do is see the wider picture about other language use and other ways of describing things.
That's a very good point, and sometimes language is very important, and sometimes it can be a bit of a minefield as well, because different people use words in different ways, and sometimes people use those words as almost like a sort of badge of honor, like
kind of reclaiming their condition, kind of like just kind of being a spokesperson for that. Just kind of what's the word? Kind of
sort of self-empowerment. Kind of.
Yeah.
Okay. Okay.
Well, I've still got Lucy over here. Yeah. Would you like a dried apricot? So how important is language? Are the large language models sensitive enough? Is it just a matter of time? Yes.
I think it's sort of a problem with the way we talk about artificial intelligence in general, that's its name, and when you're trying to talk about it, people are using words like learning and all that sort of stuff when it isn't, and even using like it instead of talking about it like it is a computer program, like people are saying that it's thinking or can it analyze and all these kind of human terms, which I don't think it's able to do, and therefore people think it's able to like make a scientific discovery, but it's just a computer thing. It's my problem.
So it's not really learning, it's not really thinking, it's not a person, it's not, it's just a program. Any thoughts on this side, Lucy?
What is it to think?
Oh yeah.
All right, we've got this technique in, okay. Nice way just to bring everyone into the conversation. Well, I'm going to turn the mirror on that question. We've got that technique. When someone asks a difficult question, come and join us. We're in a very philosophical time at the moment. This is Talkaoke Pop-Up Talk Show. We have got Margot, we've got Mia, we've got Sam, we've got Lucy, and Mikey. What's your name?
Amaka.
Was it?
Amaka. Yeah.
And I'm Mikey. And this person's going to join us as well. Yes. Well, at the moment, Lucy's just hit us with the bomb. We're talking about artificial intelligence, large language models. Mia's pointed out they don't really learn or think. They're just a program. And we keep saying they learn to do this, they learn to do that. Are they really learning? And then Lucy just dropped the bomb saying, well, what does it mean to think? What is thinking? So that's where we are right now. So we're in a bit of a philosophy. Sorry, but I'm glad you're here. Lucy, what would you say the answer to that is? What does it mean to think? Is it different from a computer program?
Well, a lot of our psychology models are based on how computers work. That's how they designed a lot of psychology models. It's a lot about inputs and outputs.
Yeah.
So you would say that they've possibly been, psychology has been developed in line with computer science, maybe.
Okay. So just when you're doing your thinking, how does it work?
I think everyone thinks differently, don't they?
I mean, do thoughts pop up? I'm going to ask other people, how do you think? And do the thoughts just pop up? Do they? Is there a process? I mean, my brain hurts already, so I must be doing some kind of work, but I'm not really sure what that work is.
No, but I think often I'll have a vague idea of what I'm trying to say, and I'll just throw it out there on the table, and somebody's gonna like complete that thought. As I was just like fumbling through my words, and I was trying to make a point about language. I think even though maybe I didn't make an articulate point, a well-rounded speech about language, I think I was definitely thinking, because I was trying to record the information that I heard, also trying to make sense of it live and link it to what you're saying. So that was, that was my imperfect way of demonstrating thinking.
So you're saying thinking is almost part of the conversation.
Yeah, that, and also it's not perfect. The process of thinking is not perfect, and I think what you get by using AI is this perfection, precision, which then kind of it just stresses me out, because then it makes me think, oh, I need to be very concise, precise, and specific, but maybe I don't.
Okay. Yeah.
I'm thinking about where this conversation kind of came from. I'm thinking like AI might be able to respond, it might be able to have conversations, in that way appear to think. But, and in terms of having a chat right now, I'm not really thinking too much before I'm speaking, as you're saying, that the words are just coming out. But I think in a genetic counselling conversation, or in anything like with PPIE work with people from the population where I'm trying to get information about research, there's a lot more thought involved before I speak, and it's using counselling skills, it's using very selective language, it's having to really consider the audience, and I genuinely think AI will fail on that. It does not think in that way.
Okay.
And I don't think it can. I don't think it has got the cultural nuances to be able to do that. And I'm seeing your job title on your thing. I'm very interested to see
What is your job title?
Strategic engagement lead, but prior to that role, I worked as an innovation lead in a network of a trust driving AI radiology. So I think the question is, when you say AI and you talk about thinking, are you referring to generative AI, because there are broader uses of AI? For instance, artificial intelligence seems to have a lot of potential in being able to be more accurate in detecting where cancers are, as well as flagging people who do not have it. And the advantage of that is the time that you would spend waiting for your biopsy report is reduced, and then people who actually have the cancers have their process expedited. So I think there's a tendency as human beings, when something is new, the default would be to be critical of it.